Hope you all can hear me. So please confirm whether if it's true or not. So let's begin the discussion now onwards. Again, if you have any issues hearing me out, then you can inform me through the chat. Okay, so again, this is the first lesson in series of the online recap sessions, which will be continued until your exam through whole 7 months. Revising most of the content of your syllabus. Okay. So in today's class, again, I think in group, I have already shared the work plan of, related to this class. So within this class, we will be revising each and every section, starting from mechanics, section wise, using MCQs. Okay. So we are mainly focusing on MCQs because in your physics exam, the final exam, 50% of marks is you can score from the MCQ paper. Actually, there are 50 MCQs. Per one MCQ, you will be given 1 mark. You can't score like that using the essay and the structured essays. That's why we have to focus more on MCQs. Okay, like one MCQ costs you 1 mark. One, like, let's say a structured essay. So in recent exams, one structured essay contains at least nearly, let's say, 10 subparts. Per one structured essay, you will be only given 20 marks, but it is out of 100. Okay, sorry, out of 200. So per one structured essay, if you calculate from 50, it will be only 4 marks. So if you divide it per 10 questions, then per one subpart you will be only getting, so you see, almost double you can score using the MCQ. Like if you do one MCQ correct, then you can directly get 1 mark in your final score. Okay, so we will continue through today's discussion then. So today's lesson is about revising Newton laws, then the friction and momentum. So these sections will be revised within today's class. Okay, so we will just start the discussion with some theory. I'm just going to recap, like remind you the three basic laws given by Newton on the motion. Okay, motion එක ගැන Newton කියපු laws තුනත් පොඩ්ඩක් මතක් කරගෙන ඉමු. So hard, very simple, three laws. First law, Newton's first law. So in first law, what he describes is the motion of an object which does not have any force. Okay, which does not have any force. Still මෙහෙමත් වෙන්න පුළුවන්. හරිද? This may have some forces, but still the unbalanced force is zero. So by the first law, he is describing about motions which are happening without a force, or there can be forces, but still the unbalanced force or the resultant force is zero. Okay. So if the resultant force is zero, what he said is this object either should be at rest, that means the velocity should be zero, or it should move at a constant velocity. Okay, simple thing. And in the second law, what he stated was when there is a force on the object, or when there is a resultant force, like when you have multiple forces, the single force which acts, like which gives the same result as the whole system of forces, we call it the resultant force. So if there is a resultant force, then in the second law, what he said is the acceleration of the object is equal to the the acceleration times mass is equal to the resultant force. Okay, F equal ma, the simple equation we know. Okay, so remember here F is not just force, but it is the resultant force. You have to consider the resultant force when there is multiple forces. Okay, so that's what given in the second law. And for the third law, it's a very like famous law, which is every action has an equal and opposite reaction. Okay, like let's say you have kept something on a table. So what happened when you keep it on the table is these two surfaces are in contact. Make a contact. So whenever two surfaces are in contact, we say there will be normal forces. Okay, normal forces will be generated. We call it normal reaction. So these normal reactions so exist like this. Okay, one reaction on the body or this object, the other reaction is on the table. This is, let's say this is a table. So this is what is explained by the third law. Every action has an equal and opposite reaction. That means if this surface is going to exert some force on this object, then the reaction force will be acting on the table. Okay, but it is in the opposite direction, but with equal magnitude. Magnitude samanai, opposite direction. So basically this means forces always generates as couples. Forces always generate as couples. Okay, so these three are the basic laws which are defined in the motion in our A-level syllabus. So we will be doing questions where these things getting applied. Okay, so we will go through each and every section in this. I think I have already uploaded a tute which contains a set of MCQs, and as well as there are some simple model questions as well. නිකන් අර පොඩි questions කීපයකුත් තියෙනවා. So those are used to just make the flow, like අර flow එක ගාලා ලස්සනට හදාගන්න තමයි ටික දාලා තියෙන්නේ. Okay, we will go through that. හරි. So first section, Newton's second law. Okay, so Newton's second law states when there is a resultant force, there is an acceleration. Okay, that means the velocity of the object will be changing. So they can be interrelated using this equation. First question: an object with mass 5 kilogram mass started its motion from rest and achieved 50 meters per second velocity in just 4 seconds. Calculate the force exerted on the object. So very simple question. Initially there is an object which is at the mass is 5 kilogram, and within 4 seconds, okay, by the time is 4 seconds, it will achieve a certain velocity which is 50 meters per second. So they are asking to calculate the force. Okay, so you can see the velocity is changing. Velocity is changing means there should be an acceleration to this direction that should be caused by a force. So we can calculate the force if you know the acceleration. That is what is stated by Newton. And even QA so how to find the acceleration? How to calculate the acceleration? Just simple definition: velocity change divided by time. Final is 50, initial 0, the time taken is 4. So 50 over 4, this will be the acceleration. So mass is given 5, so 50 over 4, it will be 12.5 into 5 means 62.5 Newton. So this is the simple application of F equal ma in a problem. I think you all can understand. So if you have anything to be clarified, just please ask at this moment. Otherwise, we will be moving very fast to some complex problems. Ini just preliminary application of this F equal ma. Okay, so the second one, again the same application. Just apply this theory, F equal ma. 25 kilogram bullet traveling at 400 meters per second pierced a wooden block. If it had traveled 5 centimeters before it got pressed, calculate the resistive force applied by the block. Okay, so it's like this. Here's a bullet. This bullet is 400 meters per second velocity, and there is a wooden. We can assume this wooden block is fixed. Okay, this is not allowed to move. Make a move in. This is fixed to the surface, and now the bullet is entering this wooden block at 400 meters per second, and it will move, travel some distance, and come to rest. Make a now. That means the final velocity is 0. So the displacement done inside is given. It is only 5 centimeters. 5 centimeters. The mass is given 25 grams. So they are asking to calculate the resistive force. So in this case, the difference is, in the previous one, the velocity increased, but this one, the velocity decreased. Inside the wooden block, the velocity decreased. Decrease in velocity means deceleration. So you all know the direction should be the opposite. The direction of the acceleration should be the opposite of the direction of velocity. Velocity can that means the force should be opposing. That's why we call it a resistive force. Again, how to calculate the same theory? Apply F equal ma, but now you can apply it to the direction of the force. So you all understand the direction of the force. So I'm applying the F equal ma equation to that direction, because when applying this kind of equations, you always have to mention a direction. In these applications, it will not that much of a matter, but still in some questions which we will be discussing ahead of this session, you will need the direction as well. If you don't consider the direction, you will not get the final answer. Answer so F should be equal to the mass is 25. මට දැන් මෙතන මෙයාගේ force එක හොයන්න තියෙන්නේ. මෙච්චර deceleration එක තියෙනවා force එක හොයන්න තියෙන්නේ. mass එක 25 but grams or kilogram කරන්න 10 to the power minus 3 වලින් multiply කරන්න ඕනේ. 25 10 to the power minus 3 into the acceleration in this direction. So acceleration මේක deceleration එකක්, but still you can calculate how. හොයන්න පුළුවන්නේ. Final velocity is 0. හරිද? Minus initial velocity is 400. Sorry, time is not mentioned, so you can't apply the direct definition. Rather, you have to apply a motion equation. See, දැන් මෙතන time එක දීලා නැහැ, displacement එක දීලා තියෙන්නේ. So I'm applying the equation without time, excluding time. And again, I want to calculate the acceleration to this direction නේ. මම ඒකින්ද මේක apply කරනවා මේ පැත්තටම. Equation එක I'm applying direction because this is again a vector equation, so you have to mention a direct when you're applying it. So the final velocity is 0. Initially, the bullet had 400 velocity square plus 2 times acceleration is to the same direction. I mark this direction, so the acceleration is the same direction. So A time displacement. So you see, when this bullet traveling from this point to this point, the displacement is to the other direction. That means this should be minus 500 to the power minus 2. Okay. So 400 squared is 16,000 should be equal to, I'm taking this whole thing into the other sign and interchanging sides. මේ තියෙන minus sign එක තියෙන කැලල මේ අගෙන sides එක mark කරනවා. අපට එහෙමම ලියමු. So 10 into 10 to the power minus 2a is equal to 16,000. So here 10 to the power minus 1. So acceleration is equal to 16 into 10 to the power 5. A very huge value. 600 බින්දු 4ක් තියෙනවා මෙතන minus 1 එකත් අනිත් පැත්තට ගියාම 5ක් වෙනවා. හරිද? meters per square second. There is a guy came to learn physics. Okay. So we can substitute that acceleration here. I'll get this minus 3 will be cancelled. This will be 400. 400 into 10 to the power 2. That means another 2 zeros. Force is 4 and 10 to the power 4 Newton. Yes, with the given answer comes. What make that? And if you have questions, just in both cases, what we did was we just calculated the acceleration, and using Newton's law, we just evaluated the force. After calculating the acceleration, we just evaluated the force. That's what happened. So these 4 questions are used to just get familiarized with this F equal ma equation. So third one, which of the following objects of mass capital M has the greatest acceleration? Okay, there are 5 options. This was a past paper question as well. They're asking which has the highest acceleration. So the simple thing is this. According to Newton's second law, if an object has some acceleration, that's because it is having some resultant force. this object gets some acceleration because that object have some unbalanced force. Unbalanced force that takes acceleration again. So all 5 answers, the mass is constant. Mass is same. Capital M. So the highest acceleration will be then when the force is also the maximum. But remember here, this F is not just the force, but it is the resultant force. Okay, make a resultant force. So the highest acceleration object get when the resultant force is highest. So you have to choose in which case there is the highest resultant. So in all these answers, you can see the 50 Newton forces are acting to the both directions. So you have to choose the answer where both 50 Newton forces are acting to the same direction. That's when the resultant is maximum. So observe that it is given in the answer 5. So for this question, the answer should be the 5th option. These two forces acting in the same direction, then the resultant will be maximum. Resultant will be maximum means the acceleration is maximum. Okay. This is the second. Okay. Then we are starting this recap session, neglecting that linear motion part. I think that's not a big deal for you guys. You can, if you work on that, giving you some time, you all can manage the linear motion thing. There are just some equation and VT graphs, and this VT graph thing will be discussed in the next session. VT graph section will be discussed. Okay. So fourth question, calculate the acceleration. This is a very famous question and kind of good one actually. Like very conventional question. Calculate the acceleration of an object which is kept on an inclined plane with theta inclination with horizontal. That should be horizontal. Okay, like this. There is an inclined plane. For this case, we assume this is to be smooth. That means there is no any friction force. We will talk about friction later. And this is the inclination angle theta. So we have to show that, calculate the acceleration of this object along this inclined plane. So we learned the Newton's laws. Here we focusing on the second law, if we ma. So you can calculate the acceleration again when you know the resultant force. That's the theory. You can calculate the acceleration when you know the resultant force, and vice versa also you can do. Like when you know the resultant force, you can calculate the acceleration, as well as when you know the acceleration, you can calculate the force also. දෙකම කරන්න පුළුවන්. Okay, so in this case, we have to calculate the acceleration. So to calculate acceleration, you have to know the force then. So we will try to sketch the forces. First is, there is the weight. Weight will be there. And again, so now onwards, we are trying to dealing with forces. So I'll be just giving a brief discussion of description of the forces which will be encountered in questions starting from this one. In mechanics, you will encounter 4 types of forces. First one is weight. Marking weight is not that hard. It is just weight is always acting downwards, and the magnitude you can calculate F equal mg. Okay, F equal mg. In the second force, we will encounter is second force එක වෙන්නේ normal reaction. Okay, normal reaction we simply denote by capital R. So we will have to work on it later. This third force is tension. Okay. I'll introduce each of these when we are doing questions of those things. And the last force is friction. මේවා හත් තමයි අපිට හම්බෙන්නේ. So mg we now mark. And then the next force we're going to encounter here is the normal reaction. And for now I just mark and I'll give a description when we solving questions regarding Newton normal reaction later. හරිද? මම මෙයා ගැන පොඩ්ඩක් කියන්නම් පස්සේ දැන්ට මාක් කරමුකෝ. ඒක කොහොමද මේකේ acceleration කරන්නේ? So you all see this object accelerates downwards along this inclined plane. So we have to consider the resultant force along that direction, because earlier I mentioned when you're using this equation you always have to mention the direction. Okay. So I am calculating the acceleration along the plane, so I have to consider the resultant force along the plane. So if I consider the resultant force, for that I have to resolve these forces. So you all see this reaction is always normal. Inclined direction is normal. It's reacting effect නැහැ. But this mg is inclined, so there will be a component coming from this mg. How if this angle of the inclination plane is theta, then this angle also become theta, and the force component along the plane will be mg sin theta. Perpendicular, it should be mg cos theta. Okay. දැන් ඔන්න forces දාගත්තන් පස්සේ දැන් මේ පැත්තට තියෙන forces විතර තියෙන මොනවාද? mg sin theta විතරයි. එහෙනම් if I apply F equal ma down towards the inclined plane, mg sin theta will be equal to ma. So mm get cancelled. The acceleration will be g sin theta. So remember this thing. This is something important. When you get like this kind of a question, just remember this point. Right? The acceleration along a smooth inclined plane is always equal g sin theta. That means the acceleration only depends on the inclination of the plane. G is a constant. G is just 10. Acceleration depend වෙන්නේ inclination angle එක මත විතරයි. Inclination එක වෙනස් කරොත් විතරයි acceleration එක වෙනස් වෙන්නේ. It does not depend on mass. මේ අතන object එකේ mass එක මත හිම depend වෙන්නේ නැහැ. Okay, so does not depend on mass. Okay. So hope you all get it. Okay, so part is done. Now I'm just recalling you some other variants of Newton's second law. හරිද? Newton's second law එක අපි use කරපු තව විදි තිබ්බා. It's not just F equal ma. Those are like this. හරිද? F equal ma we can rewrite like this. Acceleration is equal to v minus u over t. So I can modify this equation like this. Sometimes we are applying F equal ma like this. This is one variant. Okay, this is one variant. And there's another variant like coming from this. In some cases you will find mass flows. Okay, in some questions you will find mass flows, like there will be like data like this. මෙන්න මේ වගේ data තියෙන questions තියෙනවා. Mass එක flow වෙනවා. Per second there will be 2 kilogram of mass flowing. In that sort of questions, or like when there is a volume flow also, you can apply this second form. This is the same thing, but you have to consider the time with mass, m over t. Okay, so m over t means what? m over t කියලා දැන් time එක මම මේ mass එකත් එක්ක ගත්තාම m over t කවුද? Just feel it. Feel කරගන්න අපි time එකෙන් බෙදුවම rate එකක් නේ හම්බෙන්නේ. mass එකෙන් බෙදුවම mass flow rate. So this will give you the mass flow rate. Mass flow rate එක දීලා තියෙනවා මෙහෙම ගත්තාම ලේසි. So we will see two examples. Just read through the question 5. A machine gun shoots 5 bullets per second at velocity 1000 meters per second. If a bullet weighs 5 gram, calculate the force required to hold the gun while firing. Okay. So there is a machine gun firing bullets, and then there will be bullets. So all these bullets are at rest initially. Yeah, මේවා මුලදී zero velocity එකකින් තියෙන්නේ, and they will be fired. So when they are firing, they will get 1000 meters per second velocity. That means you can observe that these masses have been accelerated to this direction. So if they are accelerated to that direction, that means there should be a force. And make a force that in one direction negative. But you all know forces does not generate as single people. Single with it, forces always generates as couples. Couples ඉදිරියම තමයි එප්ප දෙන්නේ. හරිද? කතකර එක හොඳයි. හරිද? වැඩි මහාසයක් ගන්න දෙයක් නැහැ නේ. The bullets getting some force means, according to third law, there will be some force on the gun, but in the opposite direction. මම හිතලා පැහැදිලි ඇති කියලා. So gun එක මත force ගන්න ඕක තමයි හොන්න කියන්නේ. But there is no any straightforward way to calculate this force on the gun considering the gun. Gun එක සලකලා මේක හදන්න දෙයක් නැහැ, but we can consider the motion of the bullets. Bullets වල motion එක හදලා අපිට එකෙන් හදා ගන්න පුළුවන්. මොකද you can see these two forces are equal. Equal නේ. So bullets සලකමු. So if consider the bullets, I'm applying the equation to the direction of motion, and like you can see that මෙතන දීලා තියෙනවා something like this. 5 bullets per second. And the mass of a bullet is also mentioned. It is 5 gram. So you can't feel. Here in this case, using these two, you can kind of obtain a mass flow rate. 5 bullets per second. Each bullet costs 5 gram. Okay. So 5 into 5 means හරිද මේකේ තප්පරයකට 5ක් යනවා නම් විතර තියෙන total mass එක වෙන්නේ 5 into 5 නේ. මොකද එකක 5 gram. So 5 into 5 per second. That means 25 grams per second. So we have the mass flow rate. Okay, so simply you can now apply that into this equation. So the mass flow rate is 25 grams per second. Gram is not allowed. We have to make it kilogram. 10 to the power minus 3 times the final velocity the bullet get is 1000 minus the initial one is 0. Okay. So you can see the force needed to accelerate these bullets is 25 Newton. මේව accelerate කරන්න අවශ්‍ය වෙන force එක වෙන්නේ 25 Newton. So according to third law, the force on bullets, okay, force on bullets also should be force on the gun also should be the same thing, but in the opposite direction, like this. 25 the opposite direction. Okay, so that's how you apply Newton's second law in such case. Like mass flow rate එක හරි නැත්නම් velocities හරි දීලා තියෙන වෙලාවෙත් තමයි ওই විදිහට දාන්නේ. Okay. So it's one thing, and the second question also I'll do the same time, and I'll give you some time to write both of these at the end. Okay, so read the question again. Sixth one. The water jet hits normal to a wall and flow freely downwards. If the cross-section area of the jet is 40 centimeters square, velocity of the jet is meters per second, calculate the force on the wall. Okay, so there is a water jet like this. So this is gonna hit some wall. Wall like කරන්න හදන්න. The cross section area of this jet is given 40 centimeters square, and this water is coming at 10 meters per second. So we have to calculate the force on the wall. So they have said that this water flow is going to hit this wall perpendicularly. So there is no any bend due to the gravity. Gravity එකකින් බෙන්ඩ එකක් හැම නැහැ. කෙලින්ම ගිහලා වැදින්නේ. They have said hitting this wall, these will be just flowing downwards. There is no any like we call it bouncing. Bounce වෙලා අනිත් පැත්තට එන්නේ නැහැ. Okay. Again, so you experience හරිද මේ question එක කියවම you have to experience that this is a flow. Again, when you notify a flow, you should remember this. Now if you want to apply F equal ma, this is you always have to think of a mass flow rate. So මම මෙතනදී interested in mass flow rate එක හදාගන්න. So we will see how to do that. So before applying the equation, I'll just mark the force, how the forces come. Force වෙනදී පොඩ්ඩක් mark කරගමු. So you see when this මේක hit වෙනකොට මම water වලට හිතුවොත් හරිද? If you consider water, this water is initially traveling at 10 meters per second. This is the initial velocity, and finally after hitting, what will happen? After hitting this wall, this water will flow downwards. That means this horizontal velocity is 0 now. වැදුනන් පස්සේ horizontal velocity 0 වෙලා. So initially 10 තිබ්බ එක 0 වෙලා. That means water particles have decelerated නේද? Can you experience that? 10 තිබ්බ එක 0 වෙලා. That means it has decelerated due to hitting. So water particles getting decelerated means the water particles will get, the deceleration should be because of some external force acting on water. Water force acting there, and that force should be to the same direction of acceleration. Means then direction then deceleration in the direction එකේ මෙහෙට. the force එකක් තියෙනවනේ හෙට. So this is the force on water jet by the wall. Okay. Force on the water jet by the wall. So third law will say you that the same force will act on the wall but in the opposite direction. Again, you can't find this force considering the wall, but you can apply equation to the water flow. Flow එකට දාන්න පුළුවන්. So I'll consider again the water flow. So I'll applying the equation to the same direction to which the force exists. And force එක තියෙන පැත්තටම තමයි දාන්නේ. So when you use that, again you need a mass flow rate. So you have to find the mass flow rate. So this case we do it like this. මෙන්න මෙහෙම තමයි කරන්නේ. So for water flows, when they have mentioned the velocity, you can calculate the mass flow rate using volume flow rate. So the relationship between the mass and the volume is this: mass equal volume times density. This is coming from the basic definition of mass divided by volume. So if I divide both sides of this equation by time, volume divided by time is rate of change of volume. That means the volume flow rate, Q. In hydrodynamics, we prove that the volume flow rate is given by Q equal AV, cross section area times velocity. Just apply it here. මේක දාගන්න. AV rho. See? Throughout a mass flow rate හදාන්න පුළුවන් if you know the cross section area, velocity and the density. උතන දාන්න නම් පුළුවන්. So I'm applying it here. AV rho. These things you know in the question they have given the values. And the final velocity. See, once this wall get contact with this wall, the final velocity will be 0. So it is minus u means the initial velocity. So this is a special point. මෙතන පොඩි දෙයක් තියෙනවා. Here I'm applying this equation to this direction. I'm applying the equation to this direction. But the initial velocity is acting the opposite direction. හරිද? Initially water jet එක flow වෙන්නේ මෙහෙට. වදින කලින් මෙහෙට flow වෙන්නේ. Now applying the equation to the other direction. So when I'm applying the value for the initial velocity, I have to apply it minus. Minus කරලා තමයි දාන්න ඕනේ. Can you all hear me now? දැන් ඇහෙනවද? Can you all hear me now? Is it okay now? But it should be. Okay, so I think the time is enough. So I think all you all heard up to this point, right? දැන් තනිකන් ඇහෙන්නේ නැති නේද? I just explain the question. So then we are coming to the concept for these internal forces and the external forces. So I'll again give a simple brief description about this, and then we will just do the MCQ. Okay, the concept is like this. Okay, so you all now somewhat familiar with this F equal ma. I think you all should be now somewhat familiar with F equal ma, where unbalanced force is equal to mass times acceleration. When there is an unbalanced force, there is an acceleration. Okay, so how to find that unbalanced force? So when there are multiple forces, what you have to do is you have to take the resultant. When you have a couple of or multiple forces, you have to take the resultant. That's how we do it. Consider case in some problems, there are multiple masses to be considered. Masses කීපයක් තියෙනවා consider කරන්න. So when there are multiple masses, the force diagram will be somewhat complex. මේ කියන්නේ masses ගොඩක් තියෙනකොට දැන් අර force diagrams එහෙම ටිකක් complex වෙනවා. Like let's say these two masses are connected with a string like this, and some force is pulling this the forward mass to this direction. හරිද මේ පැත්තට අදින. හරිද? So if I mark the forces here, they are always the mg weights, and the reaction forces are also there, and we will talk about it later. And there is a tension for this string like this, and we will assume this case is smooth, otherwise it will get more complex. So make case එකේදී, so let's say they are asking you to calculate the acceleration of the system. හරිද? දැන් මේකේ මේ bodies දෙක වෙනම නෙමෙයි accelerate වෙන්නේ, මෙහෙම අදිද්දි දෙන්නම එකට accelerate වෙන්නේ. So they are asking to calculate the acceleration. So when you are calculating the acceleration, so what we normally learned is we just have to take the resultant force in the direction of acceleration නේ. හරිද? acceleration එකේ තියෙන පැත්තට තියෙන resultant ගන්න තියෙන්නේ. So I'm just applying the F equal ma in this direction. මම system එකම consider කරනවා. system එකම consider කරලා මේ පැත්තට සින දාන F equal ma මේ දා. So when I apply F equal ma, so what are the forces on this direction? මේ පැත්තට තියෙන forces මොනවද? These are vertical forces. මේවා වැඩක් නැහැ. So you can see F is there, and there is this tension, but you can see the tension is like here it is acting this direction, here it is acting the other direction. So if you do, I mean, if you input it to the equation, it will be like this: minus t plus t. You see, even if there is a tension, මේක දෙපාරක් යන හින්දා එයාගේ influence එකක් කරේ නෑ system එකේ acceleration එකට. So still the acceleration is only depend on this force. හරිද? මේක මත විතරයි depend වෙන්නේ. ඔන්න ඔතනින් තමයි අපි internal external case එක ගන්නෙ. අපි නිව්ටන්ස් third law එකේදී කතා කරා action reaction කියලා forces දෙකක්. එතකොට අපි question එකකදී system එකක් consider කරද්දී අපි question එකක් කරද්දී system එකක් consider කරද්දී මෙතන මම consider කරපු system එක මේ දෙන්නම system එකක් consider කරද්දී if a certain force, I mean මොකක් හරි එක force එක මේ action එකයි reaction එකයි දෙකම මේ system එක ඇතුලේ තියෙනවා නම්, if both action and reaction lies inside that system, then that force can't influence. ඒ system එකේ motion එකට influence කරන්න බෑ. මේ case එකේ නිකන් T වගේ. action එකයි reaction එකයි දෙකම ඉන්නවා, influence කරන්න බෑ. එතකොට then we call those forces are internal forces. So internal forces are happening when both the action and reaction stay inside the considered system. System එක ඇතුලේ දෙන්නම ඉඳිද්දී. External force is when external force එකක් කියලා කියන්නේ when only one action or reaction, හරිද? ඒ දෙන එක්කෙනයි. Either action or reaction stay inside the system. දෙන්න එක්කෙනෙක් විතරක් ඉන්නවනම් අපි කියනවා external force එකක් කියලා. Remember, only external forces can influence the system's motion. External forces වලට විතරයි influence කරන්න පුළුවන්, internal ඒවාට බෑ. So that is the concept about internal and external forces. Just remember, and you can after the class you can revise through your theory notes as well. notes okay, so here in this example, this is an internal force make it capillano, and this force is an external force. Make action direction so this can influence. You see, when you write the equation, F is there. Equation live F so this is concept. Okay, so question concept of internal forces as shown in the figure. Child is holding strong magnet in front of an iron trolley initially at rest on a smooth track. Which of the following statements made about the trolley is true? Trolley ගන්න කළ තියෙන statements වලින් මොනවද කියලා අහන්නේ හරිද? මේක simple theory එකක් හරිද? මේකේ magnet එකක් දාලා ඉස්සරහින් අදිනවා කියලානේ කියන්නේ. So the magnet is going to apply a certain force on this iron trolley, but can it influence a motion? Motion එකක් influence කරන්න පුළුවන්ද? Case is this: the magnet will somehow give a force on this trolley, but according to third law, this is not the only force නේ, මේක විතරක් නෙමෙයි තියෙන්නේ. According to third law, if the magnet is going to exert some force on this trolley, then the opposite reaction will be some force on the magnet, but in the opposite direction. Magnet එක මත ඒක reaction එක එනවා. So when you consider the whole system, this is an internal force, so this can't influence the motion. That means the system will not move. So the answer should be the fourth one. For the seventh question, the answer should be the fourth one. Only external forces can influence a motion. Internal external concept එකක් දැන් පැහැදිලි ඇති. Okay, so now we will see the first type of force to be discussed, the normal reaction. Normal reaction. Again, I'll quickly introduce this and we'll go through the cute questions. Normal reaction is when two surfaces are in contact. Okay, when two surfaces are in contact, there will be perpendicular forces generating. These we called normal reaction forces. Normal reaction forces. And remember, these normal reaction forces are self-adjusting. Okay. These forces are self-adjusting. Self-adjusting forces means normal reaction is capable of adjusting its size or its magnitude according to the case. යන්න පුළුවන් එයාගේ ඉන්න case එක අනුව magnitude එක වෙනස් කරගන්න. So we will see through some questions. Eighth question, C. Question number 8. An object of mass m is kept on a compression balance which is in an elevator. Calculate the reading of the balance when elevator moves with. First one, certain cases කීපයක් දීලා තිනවා. මේක හොඳයි නිකන් theory එක පැහැදිලි කරගන්න. So first thing, reading of a compression balance. Remember, the reading of a compression balance is nothing but the normal reaction. Okay, normal reaction එක තමයි reading එක වෙන්නේ. So let's see how the normal reaction behaves in each case. First one, the elevator is moving at a constant velocity. Okay, so I'm going to mark the forces on this object. Definitely there is the weight, and then due to this contact there is the normal reaction. So we want to calculate this reaction, then only we will get the reading. කොහොමද reaction එක ගන්නෙ? I just have to consider the motion of this object moving at a constant velocity. This is explained by first law, Newton's first law. If it is moving at the constant velocity, then the unbalanced force should be zero. There should not be any unbalanced force. Unbalanced force at the then this case reaction should be mg. Okay, first. Next thing, uniform acceleration 0.5 g upwards. Now the mass is accelerating upwards at 0.5 g. Again, the same forces are involving, but now there is an acceleration. Acceleration at the So how to do this? You just have to apply F equal ma. When there is an acceleration to relate with forces, you can apply Newton's second law. For the previous one, it was first law. Here, second law. So when you apply Newton's second law, the upward force is R minus mg. Upward unbalanced force is R minus mg is equal to ma. So upward unbalanced force R minus mg should be equal to mass times the acceleration. So R should be equal to mg plus a. So here the acceleration is given 0.5 g. That means the reaction here should be 1.5 mg. So you see, in different cases, the reaction changes its value to according to the situation. A situation adapt කරන විදියට value එක change කරගන්න පුළුවන්. That's why we call this reaction is a self-adjusting force. So the last example, again the same two forces on this object, but now the elevator is accelerating downwards at 0.4 g. Elevator is accelerating downwards at 0.4 g. Okay. So in this case, the මෙතනදී F equal ma තමයි දාන්න තියෙන්නේ. මොකද accelerate වෙනවා කියන්නේ F equal ma දාන්න ඕනේ. And just practice හරියට practice කරන්න the F equal ma සාමාන්‍ය apply කරන acceleration එකේ තියෙන පැත්තට. Yeah, applying the F equal ma formula to the direction to which the acceleration is happening. So it's happening downwards නේ. So when I apply F equal ma downwards, so I should consider the resultant force downwards. පල්ලෙහාට resultant එක ගන්න ඕනේ. What is it? mg is there, R is into the opposite direction. So mg minus R, this is the unbalanced force, it should be equal to ma. So in this case, the reaction is mg minus a. Okay. මේවා මතක තියාගත්ත ප්‍රශ්නයක් නෑ නේද? You may remember this one. If the elevator is accelerating upwards, then the reaction is mg plus a. If the elevator is accelerating downwards, it is mg minus a. So for this case, what is the value? Here the acceleration is 0.4 g. So when you do the respective math, you will find the reaction is 0.6 mg. Okay, so the last part also the same thing. If you put g here, the reaction will be 0. So I'm not gonna do it now. So we will go to question number 9. So that's a past paper question coming from this motion in elevators section. So you can just go through this document. So if you can solve these, you just have to solve and try the next question. Likewise, you have to complete it. And if you find something unclear, then you have to wait until I come to that point. Okay. And if you have any questions, again you can put in the chat box. Okay, 9th one. When a mass is suspended vertically by a light string from the ceiling from the ceiling of a stationary lift, the extension of the spring is found to be x naught. The extension is found to be x naught. If the lift is then set in motion in the vertical downward direction so that its velocity varies with time according to the graph shown in the figure. The variation of the extension of the spring with time t best represented by. Alright. Okay. Question is about some. I think. Okay. So me question nigga. Let's say the same question, but not the extension of a string. ඒකත් එහෙම තමයි වෙන්නේ. ඒක අපි පස්සේ දැන් කතා කරමු. මොකද මම දැන් normal reaction එක ගැන කරගෙන ඉඳලා හරිද? එතන මේ type කරන්න දුන්න කෙනා වෙන එකක් type කරලා තියෙන්නේ. Here let's say there is a compression balance. හරිද? compression balance එකක් තියෙනවා. මේ compression balance එක උඩ mass එකක් තියලා තියෙනවා. ඒතර elevator එක පල්ලෙහාට ඔය කියන velocity එකකින් යනවා. And this VT graph is like this. We have to consider this VT graph, and let's say you have to sketch the variation of extension or compression of this balance. මේ balance එකේ compression එක. මේ balance එක ගත්තාම මේක compression balance එක ගත්තාම මේක compress වෙනවනේ. අන්න ඒක උදාන තියෙනවා කියලා. So just remember the compression is proportional to the reaction. compression එක proportional reaction එක කියන්නේ reaction එක වැඩි නම් compression එක වැඩි, compress වෙනවා වැඩි, reaction එක අඩු නම් compress වෙනවා අඩුයි. Let's assume like that. Okay, so how to do this? So you can see මේ question එකේ කියලා තියෙනවා මේ elevator එක පල්ලෙහාට move වෙන්නේ. move වෙද්දී velocity එක වෙනස් වෙන විදිය දීලා තියෙනවා. In each case, if you consider the acceleration, how it behaves. In the first interval, there is a positive acceleration. මට කියන්නේ මේ graph එක දීලා තියෙන්නේ පල්ලෙහාට motion එක හරිද? ඒතර in the first interval there is an acceleration downwards. Because the acceleration is positive means should be downwards. හරිද? graph එක කියන්නේ question එකේ දීලා තියෙන motion එක දීලා තියෙන්නේ පල්ලෙහාට යනවා කියලා හිතලා. ඒතර graph එක positive පැත්ත නම් acceleration positive වෙන්න ඕනේ. පල්ලෙහාට තමයි positive acceleration තියෙන්නේ. For this section මෙතන velocity එක වෙනස් වෙන්නේ නැහැ නේ. Velocity stays constant means the acceleration is 0. So in this section the acceleration is 0. For the next section, you can see the velocity is decreasing. That means the acceleration is negative. Here velocity increases, this is constant, and this is decreasing. Decreasing means acceleration negative. So again remember they have mentioned the downward motion as positive. So if acceleration come negative, that means the acceleration should be upwards. හරිද? මෙතනදී acceleration දිනවනේ උඩට. එතකොට acceleration එක මෙහෙම තියෙනකොට කොහොමද reading එක එන්නේ? මේකම formulas ටික අපි ගත්තා. හරිද? acceleration එක පල්ලෙහාට නම් reaction එක එන්නේ g minus a. acceleration එක උඩට නම් reaction එක එන්නේ g plus a. ඊට acceleration එක නැත්තම් like here acceleration එක නැත්තම් reaction is m. Okay, so the extension depends on the reaction නේ. ඒතර මෙතනදී ඔයා දකින්න මේ තියෙන values තුනෙන් කවුද අඩු කවුද වැඩි? මොනේ මෙයා තමයි අඩුම. හරිද? g minus a. ඊට වඩා ටිකක් වැඩි මෙයා mg. ඊට මෙතන g plus a තියෙන හින්දා මෙතන තව වැඩි. ඒතර මෙතනදී reactions ගත්තොත් මේක මම r1 මේක r2 මේක r3 කියලා ගත්තොත් r1 ට greater r2 ඊට වඩා greater r3. හරිද? r වැඩි වෙනවා කියලා කියන්නේ ඔයාලා දෙනවා r වැඩි වෙන පැත්තටම තමයි x උත් වැඩි වෙන්නේ. that means x1 ට වඩා වැඩි වෙනවනේ x2 ට වඩා වැඩි වෙනවනේ x3 regions තුනේදී compression එක. So how should it behave if you draw the graph? Initially x should be the lowest like this, and again for this period of time the acceleration is positive and it is constant නේ. මේ period එකේදී මේ acceleration එක constant නේ. acceleration එක constant කියන්නේ reaction එක constant. reaction එක constant කියලා කියන්නේ x උත් constant වෙන්න ඕනේ. So within that time period that x value does not change. It should be constant. So for the next time period again it should be somewhat higher, but it is again constant because again the acceleration is not changing. Acceleration is not changing, reaction is not changing, x also does not change. And for the last section again it is higher than the previous one, but it is again constant. So the graph should look like the one given in the first answer. First එකේ කියන එක තමයි එන්න ඕනේ. Okay, so hope you all got it. Question number 10. So I'll give you some time to take a note if you want. Okay, so question number 10. Two blocks A and B of masses 2 kg and 1 kg respectively are kept in contact on a frictionless table when a horizontal force F is applied on A as shown in the figure. The force exerted on B by A is 1 Newton. Okay. If instead the same force is applied on B in opposite direction, the force exerted on A by B is. Okay. So there's a case like this. So can you all hear me? Thank you. Okay, so there's the A and B, and certain F force is applied. Okay, so I'll briefly explain the theory behind this, and then we will do this question. So ඔය වගේ case එකක් දුන්නාම හරි when there is question like this හරි masses කීපයක් එක දිගට තියලා there is a force given to the mass behind හරිද behind තියෙන mass එකට දෙනවා force එකක්. So you have to understand this when this force is applied, this behaves as a system නේ. this whole set of mass accelerate as a system. System accelerate mainly. So you can determine the acceleration for the system as well. You don't need to include the internal forces. Just the external force will be this. So F should be equal to ma plus mv times acceleration. So you can easily find the acceleration. Acceleration is just caused by the external force. With an external force in the accelerate when. But still, if you mark all the forces, what should be there? One of the forces. Vertical forces be there. But vertical forces පොඩ්ඩක් mark කරන්න නැතුව ඉන්නම්. Horizontally තව මොනවද මේ system එකේ forces තියෙන්නේ? So if you search for horizontal forces, you should understand these two surfaces are in contact. So if any two surfaces are in contact, there should be a reaction force perpendicular to the surface. Surface eකට perpendicular තියෙන්න ඕනේ. So there should be some reaction here. But when you are considering the system, it is an internal force, okay? When you are considering the system, interaction එක reaction එක දෙකම ඇතුළේනේ. So it is a internal force. That's why it was not included in the first equation. මෙතනදී ආවෙ නැත්නම් ඒකයි. Internal forces can't influence. But මෙහෙම කෙනෙක් ඇති වෙනවා. So there should be some way to determine this S as well. මේ S කියන එක නම් හොයන්න විදියක් තියෙන්නත් එපයි. How? Again a simple trick. Make an internal force එකක් විදිහට තිබ්බොත් නේ influence කරන්නේ නැත්තේ. This does not influence when this is when the force is kept as an internal force. But what if it is an external force? So I have to consider මම මේක external force එකක් විදිහට ගත්තා නම් හරිනේ. මට simple පොඩි trick එකක් කරන් තියෙන්නේ. මම system එකක් consider කරනවා මෙයා external force වෙන විදිහට. I'm just considering only B. So when only B is considered, the external force on B is S. So S should be equal to mass times its acceleration in B times acceleration. So that's how you have to determine the value of S. Okay, the acceleration is initially found, so you have to apply the value here, and then you can determine S as well. That's the normal procedure of like calculating internal forces. මෙතනත් ඒ වගේමයි. There is some if force is given to the A, weights are given 2 kilogram and 1 kilogram. So when the force is applied on A, there is a reaction between these two. The force on B reaction is they have given 1 Newton. 1 Newton. And they are asking to calculate the same reaction if that same force is given to the other object. That means to B. The external force එක B ට දුන්නා නම් මෙතන reaction එක එන්නේ කීයද කියලා තමයි හදන්න කියන්නේ. So let's mark the reaction, new reaction as R. So consider the first diagram. මෙතන අපි හදාගන්න බලමු මේ දැන්. මේ force එක දුන්නාම මෙතන reaction එක 1 Newton වෙනවනේ. So we will try to find the acceleration of the system. මේකේ system එකේ acceleration එක හදාගන්න බලමු. ඔයාලට තේරෙන්න ඕනේ දැන් මේ system එකට F force එක දීලා තියෙද්දි නම් මේ acceleration එක ආවේ A force එකම පැත්ත මාරු කරලා දුන්නා කියලා acceleration එක වෙනස් වෙන්න දෙයක් නැහැ නේ. And same force here and here. And the same system, same set of masses. මේ පැත්තට දුන්නොත් යන acceleration එක අනිත් පැත්තටත් යන්න ඕනේ. හරිද? So we will try to determine the acceleration from the first diagram. හරිද? පළවෙනි diagram එකේ acceleration හදාගන්න පුළුවන්. So consider the first one. Acceleration determine කරන්න පුළුවන් force එක දන්න වෙලාවේදී. So we should be somewhat like පොඩ්ඩක් කපටි වෙන්න ඕනේ. හරිද? So system එකම ගත්තොත් මම මේ F කියන එක දන්නේ නැහැ. So we can't calculate the acceleration. But if you only consider B, we know the reaction. When the system is considered, this is an internal force. But if only B is considered, this is an external force. Right? So B, when we write the equation, 1 should be equal to 1 times A. So acceleration should be 1. The same acceleration should be here. මෙතනත් තියෙනවනේ ඒකමයි. So when we apply again, now again I don't need this F. So without F, I have to find R. So if I have to find R, I should consider a system where this R is an external force. R external වෙන විදිහට system එකක් ගන්න ඕනේ. That means if I consider only 2 kilogram, then the external force is R. R with the external in. Action is only there, not both action and reaction. So I'm considering A. I'm applying F equal ma. Okay. So the only force is R. R should be equal to its mass is 2. And the acceleration. So you should understand, if the same force is used, the acceleration is in the first case should be the same acceleration for the second case as well. So the reaction should be 2 Newton. That is, the answer is 2 Newton. That is the third answer. If you have any questions, just mention the chat. So when you are doing this, make your own notes. You can make your own notes when it is needed. I'm just discussing and explaining the theory. So when you find something kind of like new for you, just make a note. Okay. And clear වැඩේ කරන්න යන්න. Otherwise, we will run out of time. That's why, so like in the yesterday session also I mentioned, yesterday we started our unique paper class series. So there we will be writing a series of papers. First few will be revising the syllabus, and the next few will be like making you to a state confidently face your exam. Confidently exam එක face කරන්න පුළුවන් වෙන විදිහට හදනවා. So in this session, what I'm doing is I'm just giving you the push that you need to revise through the syllabus. Syllabus එක through revise කරන්න අවශ්‍ය push එක තමයි මම දෙන්නේ. So within that week, you should be able to cover the certain content. ඒ content එකේ තියෙන ඉතුරු ටික ඔයා cover කරගන්න ඕනේ. That's how we proceed through these 20 days. Okay, so now discussion is on tension. Tension. So these tension forces, I'll just give an introduction. There's a string or a rod. If you pull it to the opposite direction, from both sides, sides දෙකෙන් ඔයා pull කරොත්, then the forces exerted on this object or the string or the rod, we call them tension forces. මේක ඇතුළේ තියෙන forces අපි කියනවා tension forces කියලා. But when marking the tension forces, note that tension forces mark කරද්දී අපි මේක අදින්නේ මෙහෙමනේ. We are just pulling this like this. When we are marking the tension forces, we do the opposite. We කරන්නේ opposite දේ. Actually, what we are doing is we are marking the forces not on the string. Like අපි mark කරන්නේ string එක මත තියෙන forces නෙමෙයි. We are marking on the string the forces which are acting at the end objects. කියන්නේ මේ string එකේ මේ දෙපැත්තට high කරලා තියෙන objects තියෙනවානේ මොනවා හරි. අන්නේ objects මත තියෙන forces තමයි අපි string එක දිගේ mark කරන්නේ. We are only marking the forces acting on the objects which are connected to the ends. ends වලට connect කරලා තියෙන objects වල තියෙන forces තමයි මේ mark වෙන්නේ. හරිද? So these are the tension forces. Again, so this is the normal way of marking tension. This is the normal way of marking tension, and we will see how the tension behaves in different cases. So before going there, again I have to make sure, mention this tension force is again a self-adjusting force. Tension force කියලා කියන්නේ self-adjusting force එකක්මයි. එයාගේ value එක එයා depend වෙන විදිහට වෙනස් කර ගන්නවා. So we will go through the first few examples. First, they have given set of pulley system එකක් දීලා තිනවා. tension එක හොයන්න. හරිද? Find the acceleration of the following pulley systems and the readings of the spring balances. And this thing about the reading of spring balances. Remember, reading of a spring balance is nothing but the tension of the string under the balance. That means, let's say the spring balance is connected like this, and there is a string below the balance. So the reading of this spring balance is nothing but the tension on this string. The string tension එක තමයි reading එක වෙන්නේ. So in all cases, we have to determine the tensions of the strings. Okay, first one, very easy type question. So I'll just remind you this pulley type questions. There is an 8 kilogram mass and 2 kilogram mass. So first of all, you have to mark all the forces on this pulley system. So definitely the weights are there, 80 Newton and 20 Newton. And then there's this string. So along the string, there are tension forces. මේක ඇදලා තියෙන tension forces තියෙනවා. So how do we mark the tension forces? You see, the tension forces are always marked into the string. String ඇතුළට කොහොමද? මෙතන පෙත්‍රන විදිහට තමයි mark වෙන්නේ. And again, remember, in case of when the pulley is frictionless, as well as the strings are massless, and the strings වලට mass එකක් නැත්නම් මොකද තියාගන්න මේ string එක හැම පැත්තම tensions සමානයි. That means the tension of this side should be the same thing on this side. හරිද? මේ පැත්තම සමානයි. So එහෙම සිස්ටම් එකක් තිබ්බම you should understand මේක තිබ්බහම මේ පැත්තේ weight එක වැඩිනේ. So because of that higher weight, this side will accelerate downwards. because පල්ලෙහාට accelerate වෙනවා. At the same time, when this accelerates downwards, the other side will accelerate upwards. So how to determine the accelerations? Just apply F equal ma to the objects. හරිද? වෙනනම් දාන්න. 8 දැම්මහම පල්ලෙහාට යනවා 80 minus t is equal to 8a. 2 kilogram ට දැම්මහම උඩට හරි acceleration එක තියෙන පැත්තට තමයි F equal ma use කරන්නේ. හරිද? We are using F equal ma to the same direction of the acceleration. So 2 ට දැම්මහම unbalanced force එක වෙන t minus 20. So t minus 20 is equal to 2a. When you add this, 60 is equal to 10a. A is equal to 6 meters per square second. Okay. So the acceleration is found. Now for tension, you can solve any of these equations out of 1 and 2. So I'm going with 2. From the second equation, I can calculate the tension to be 20 plus 2 into 6, which is 32 Newton. Okay. Tension is 32 Newton. Same type of question එකක් තියෙනවා මේකේ තුනම එකමනේ. මම second එක කරන්නේ මම third එක කරන්නම් අර spring එක තියෙන හින්දා මේ spring balance එකේ reading එක පෙන්නන්න. හරිද? So in the third example, here there is this spring balance and there is the weight like this 1 kilogram, 1 kilogram. Here is a 3 kilogram. Then what you have to do is you have to mark all the forces 30 Newton, 10 Newton, 10 Newton weights, and then the tensions. Tensions mark කරන්න දෙබේ. මොන පොඩක් බලාගන්න. When you are marking tensions here, understand this is one string and this is another string. Within strings දෙකක්. So there is nothing like, there is no any conditions like all the strings have the same tension. හැම string එකකටම එක tension එක තියෙනවා කියලා එකක් නැහැ. We don't know the tensions are equal or not. So what we do is we assume two different tensions. So I'm marking here T1 along this first string T1. Along the second string, the tension is T2. I'm just marking. Don't know whether they are equal. We can see once write the equations. Okay, now all the forces are marked. Now see to which direction this accelerates. So the pulley system is called accelerate pending. When you put the masses like this side is heavier. This side is heavier means this side go down. So the acceleration will be down for this side and it will be up for this side. So when you now you have found the direction of accelerations, now you have to apply F equal ma. Objects are F equal ma දාන්න තියෙන්නේ. So I'm applying for the 3 kilogram first downwards. When downwards is applied, 30 minus T1 is equal to 3a, first equation. And then you see this spring is also traveling this spring spring is also moving downwards. So we have to consider the motion of this spring as well. Spring at F equal ma දාන්න වෙනවා. So how to do that? So spring එක මත තියෙන forces මොනවාද? T1 එකක් තියෙනවා පල්ලෙහාට. එයාගේ weight එක තියෙනවා and T2 තියෙනවා. So I'm applying the equation to the direction of acceleration, that means downwards. N plus T1 minus T2 is equal to 1a. Second equation. And for the 1 kilogram here, it is accelerating upwards. So I'm applying the equation upwards. T2 minus 10 is equal to a. Third equation. So the best way to solve this is just add these three equations. මේ equations තුන add කරපුවම ඔයාලට බලන්න පුළුවන් මේවත් හැපේ යනවා අනවශ්‍ය දේවල්. හරිද? There will be only the acceleration. හරිද? When you add these three equations, minus T1 plus T1 will be cancelled and minus T2 plus T2 will be cancelled. So 30 plus 10 minus 10 is equal to, the other side is equal to 4a, sorry 5a. So the acceleration is 6 meters per square second. You see, 6 meters per square second. So I'm interested in the tensions as well as the spring balance reading. So first I'll evaluate the tensions. From the third equation, T2 should be 10 plus 6, which is 16 Newton. And from the first equation, T1 should be 30 minus 3 times 6, which is 12 Newton. Okay. So what should be the reading of this spring balance? Reading is nothing but the tension under this balance. The balance is here. The tension under is T1. This 12 Newton. Reading is 12 Newton. So that's how you find the reading of a spring balance. Just the tension of the string under the balance. Okay. So that's about question number 11. Question number 12. Question number 12. Again, just notice I'm going to like kind of touch a big region. Like when you're learning these theory parts in the theory class, you will spend weeks like this content, this whole content, Newton's laws, friction, and the momentum. This whole thing will require at least 3 to 4 weeks. I'm just trying to cover it within like 3 hours. So uh, I'm touching each and every part which is important. So you have to work on those parts within that week. Okay, that's what is expected from your side. Um, Question number 12. Figure A shows two blocks of height 100 Newton. That should be weight 100 Newton and 400 Newton, which are connected by a light string that passes over a frictionless poly. Figure B shows the situation when the heavier block in the system is removed and the string is pulled downwards, pulled by a downward force of 400 Newton. The respective accelerations of 100 Newton block in the two situations are given by. Okay. Situations දෙකේදී reactions දෙකනේ අහන්නේ. So the thing, first one is easy. First one එකේදී ඔයාලට කලින් විදිහටම tensions mark කරගෙන හදන්න තියෙන්නේ. හරිද? So same case. So one side the weight is 400, the other side is 100. So when you apply the equation to the side which is moving downwards, 400 minus t is equal to 40a, and to the other side which is going upward, it is t minus 100 is equal to 10a. So when you add these two up, 300 will be equal to 50a. So the acceleration should be 6 meters per square second. Okay, 6 meters per square second. For B, what is the difference in B? So some students may confuse this with the first, which is in A. Confuse they think both of these are the same situation. And just identify in the second case there is no any mass. In the heavier side there is no any mass. There is only force which is 400 Newton. Force is directly equal to 400 Newton. What happens when you apply a force like this? When you apply a force like this, the thing happening is the tension of the string now is directly equal to the 400 Newton. Okay. In the previous case, when you keep 400 Newton weight, the tension is not equal to 400. Tension is something less, some value which is less than 400. If you find, so just substitute 6 here. When you substitute, you will see that the tension is 160 Newton, only 160 Newton. But in this case, when you do this, the tension will be 400 Newton. That means if you apply F equal ma for the other part, you will see 400 minus 100 is equal to 40a. So yeah, 10a. So here the weight is equal to 100 kg. Weight 100 kg, mass 10 ne. Mass 10 grams ne. Just dividing by the gravitational acceleration. So 300 is equal to 10a, a equal to 30 meters per square second. That means in this case the acceleration is much higher. So this is given in answer 5. So identify කරගන්න හරියට situations දෙකක් හොඳේ. In one case there is this 400 Newton weight. Okay, so the tension is not equal to 400, but tension is something less than that, 116. But in the second case, the tension is directly equal to 400. Then the acceleration is much higher. Okay. So 13. This is again a very simple question, and I think I don't need to explain that much of this, because the same kind of question we involved in the reaction when we are talking about the normal reaction as well. The normal reaction එක අර intermediate internal force එකක් හෙව්වේ ඒ විදිහම තමයි, but now these two are not touching each other but connected with the string, piece of string. So two masses are joined by a right string and pulled along the smooth table as shown in the figure. What is the tension of the string? They are just asking the tension. So you see, if you consider the whole system, this is a internal force. So first you have to consider the whole system and find the acceleration. So when the whole system is considered, this is an internal force, so it can't influence. Only external force is 20, so it does affect the motion. 20 should be equal to total mass is 10 times A, so the acceleration is 2 meters per square second. So once you find the acceleration, you can evaluate the tension just by selecting a system to which that tension become an external force. So such system, the most uh, simplest one is 4 kilogram. Just consider 4 kilogram object. So when you apply F equal ma considering 4 kilogram, the only external force is now T. T should be equal to 4 times the acceleration is 2, that is 8 meters per square, sorry, 8 Newton. So answer is the second answer. Sorry. Okay. See, in each of these cases, the tension adjusts according to the situation. The value of the tension adjusts according to the situation changes. Yes, tension can also be down. Tension can also be down. Okay. 14th, when a train is moving, pendulum hung from the roof of a train shows an inclination theta with the vertical direction. Calculate the acceleration of the train in terms of theta. So this is also one of the beautiful questions you found regarding tension. We just spoke the tension is a self-adjusting force. The value depends on the situation. It adjusts according to the situation. So when the train is moving or accelerating in this way, if you hung something from the roof එකෙන් ඔයා මොනවා හරි එල්ලලා තිබ්බොත්, you will see that this will incline to the opposite direction. හරිද? accelerate වෙන්නේ මෙහෙට නම් object එක incline වෙන්නේ opposite direction එකට. Like this. Simple scenario. So they are asking to build up a relationship between this theta and the acceleration. Calculate the acceleration of train in terms of theta. හරිද? මේක හොයන්න කියනවා theta වල terms වලින්. So let's consider the forces on this. First, the weight is there. Weight of the object is there. Second, there is a string, that means the tension force is also there. So these two are the only forces acting in this situation. මේ දෙක විතරයි තියෙන්නේ. So when explaining this question, the best way is to so this tension force is inclined. Tension force is inclined. But when we are describing motions, we are mostly what we are doing is we are considering the horizontal direction and the vertical direction. For that we need to resolve this tension. Then we incline thing තියාගෙන හරියන්නේ නැහැ. Resolve කරන්න ඕනේ. So when you resolve this, if this angle is theta, this angle should be theta. This alternative angles. So if it is theta, then the component along this side should be t sin theta, and the opposing the vertical component should be t cos theta. If anyone does not remember what is resolution, resolution means you can replace this single force with two forces in perpendicular to each other. Perpendicular forces they can never replace current. Okay, now we can think easily. So first we will think of the vertical direction of this motion. When you consider the vertical motion of this pendulum, this is only accelerating horizontally. This is only acting horizontally, and there is no any vertical motion. No vertical motion means in vertical direction forces should be in equilibrium. Forces equilibrium at the end. That means this t cos theta should be equal to mg. And when you consider the horizontal motion, this t sin theta should be the force which causes the acceleration. Okay. So when you apply F equal ma to the horizontal direction, the resulting force on this object is t sin theta. So t sin theta should be equal to mass times the acceleration. So first equation, second equation. When you divide these two equations, you can get rid of this t. For the equation t අපිට ඕනේ නැහැ. මම t කියන එක නාතින් දාගත්ත කෙනෙක්නේ. So sin theta over cos theta is equal to ma over mg. So m is getting cancelled, and sin theta over cos theta means tan theta. Tan theta is equal to a over g, and now you can get a formula to acceleration, which is acceleration is equal to g and theta. This thing also you can remember. For some questions you can remember this. ඉතින් තේරුම් ගන්න මෙතනදී මෙයා incline වෙන්නේ. This pendulum just incline to the opposite direction for what? Incline වෙන්නේ. Because if it stays horizontal, if the string was horizontal, then all the forces on this object will be horizontally. So there is no way to achieve that acceleration. If you consider the pendulum does not have any kind of method to achieve that horizontal acceleration. The horizontal acceleration. So then what happens is, to obtain that acceleration, automatically this tension incline. So once this tension is, the string is inclined, what happens is there will be a horizontal components of this tension coming in this way, which will be enabling the object to accelerate in that way. Tension component එකෙන් තමයි acceleration එක හදාගන්නේ. So I think things are clear for you, and if you need time, just take a note quickly. 15th is very similar to the one we discussed earlier about the normal reaction in the elevator. Okay. Question number 15. That's a question about an elevator. Very similar one. Uh, Five kilogram mass is hung using a spring balance inside an elevator, initially at rest. Calculate the reading of the spring balance if the elevator is moving constant velocity or rest, accelerating upward, accelerating downward, decelerating downwards. Okay, four cases. Uh, I just consider the first three. In this case, it is at rest of velocity 0 or constant velocity. That means the acceleration is 0 simply. The second case, accelerating upward. Third case, accelerating downward. So how the tension behave? Again, you have noticed this is a self-adjusting force. That means it changes its value from the situation. Situation adaptation. So in the first case, there is no acceleration, or it is the velocity is 0 or constant velocity. That means this is described by the first law. This is described by the first law. So the unbalanced force should be 0. That means the forces should be balanced. So first case T equal mg. And this is now accelerating upwards. When you consider this mass, if you apply F equal ma upwards, the unbalanced force upward is T minus mg. It should be equal to mass times acceleration. So tension should be equal to mg plus a. Okay. So the third case, this is accelerating downwards. So apply F equal ma downwards. So the downward resultant force is mg minus t. I'm just considering the result force downwards. මේක downward accelerate වෙනවා කියන්නේ result එක downward නේ තියෙන්නේ. එහෙනම් අනිවාර්යෙන් mg වැඩි වෙන්න ඕනේ. හරි. If you consider these two, mg should be greater than this t. So mg minus t should be equal to ma. So here you get t equal mg minus a. So you see the similar behavior as seen in the normal reaction. Normal reaction එකේ වගේම තමයි. හරි. අභිලම්බ ප්‍රතික්‍රියාව වගේම තමයි. Accelerating upwards means d plus a, accelerating downward means d minus a. උඩට accelerate වෙනවා නම් g plus a, පල්ලෙහාට accelerate වෙනවා g plus g minus a. So you can use the given values, apply the values, and take the given answers. So I'm not going to do that. So I just want to remind this. හරිද? මේක remind කරන්න විතරයි මට ඕනේ උනේ. So if you want to take notes, please be quick on that. I'll be moving on to the next problem. And here in the fourth part, so fourth part they say decelerated downwards. So the elevator is decelerating downwards. So decelerating downwards means it is reducing its downward velocity. පල්ලෙහාට තියෙන velocity අඩු වෙනවා. That means the direction of acceleration should be upwards. So like මෙච්චරයි හරිද? In the given case, what we have to identify is the direction of acceleration. So once you identify the direction of acceleration, it will always fall into these three types of cases. And අනිවාර්යයෙන්ම මේ තුන එකක් තමයි එන්නේ. So here decelerating downwards means the acceleration should be upwards. So it should be the second case. Acceleration උඩට තියෙන දෙවෙනි case එකනේ. So just use this formula and substitute the given values and take the answer. That's how you do it. Okay, so I think this part is also clear for you. The 16th question. That's not actually a big question, හරිද? Not a big question. Two masses, capital M and simple m, are placed on a frictionless horizontal surface are connected together as shown in the figure using a spring whose mass is negligible. මේ mass එක negligible spring එකකින් මේක connect කරලා තියෙනවා. Two masses are first pressed together so that the spring is compressed and then released. Mistake, yeah. If the initial acceleration of mass m is a, what should be the magnitude of the acceleration of capital M at that moment? So what they have done is they have pressed this and make it free to accelerate. So initially the acceleration of this object is a, and we have determined the acceleration of this one, let's say a dash, in terms of the previous acceleration of simple M. Simple thing. So the same spring, so you know, හරිද මේක දැන් ස්ප්‍රින්ග් එකක් වුණත් ස්ට්‍රින්ග් එකක් වුණත් ඒක massless නම් light නම් හරිද light නම් මතක තියාගන්න හැමතැනම tension එක සමානයි හරිද tension at each place is similar. So here when this is pressed, actually it is not a tension, it is a compressive force. So when it is pressed, the force developed on this capital M is this, sorry, simple M. The force developed on this simple M is like this. So the same force is developed on capital M as well. So apply F equal ma to simple M. So this T causes simple A acceleration. So T should be equal to simple M times A. Then if I use the same formula to capital M, the same force is there. Tension is equal to simple ma. I found it earlier. So I'm applying it here. So tension is equal to capital M times A dash now, and tension is ma, simple ma as well. So A dash should be simple ma divided by capital M. You see? So the answer is very straightforward, which is the third answer. Okay. So it's a very easy question. අන්දනේ වන වස්තුවක තියෙන වතුර බාධනය Yeah. So the person who asked this question, you can ask it in direct message. Okay. මේක දැන් මට ක්ලාස් එකේ පැහැදිලි කරන්න ගියොත් මේ නිකන් time waste වෙනවා විතරයි. හරිද? ඒක that we don't need to worry about that much of thing for this section. හරිද? ඒකේ මේ ඉන්නේ check කරන එකනේ. So if you have such questions like මේවා තියෙන්නේ අර ඔයාලට අන්තිමට කරන්න වැඩක් නැත්නම් ස්ටඩි කරන්න විතරයි. හරිද? කියන්නේ ඉස්සෙල්ලා syllabus එක අඳුර ගන්න. Then you can do this kind of question. හරිද? ඔයා මේක මට direct අහන්නකො. يعني direct message එකක් මට දාන්න මම ඒක පස්සේ බලලා කියන්න. හරිද? Okay. So now friction. Okay. So an interesting part, friction. Actually, most of the students get this friction thing very difficult, but it's a very easy part. මේක අමාරු part එකක් නෙමෙයි friction කියලා කියන්නේ නිකන් force එකක් විතරයි. just පොඩ්ඩක් behavior එක අඳුර ගන්නදී පොඩ්ඩක් පටල ගන්නවා. හරිද? ඕක තමයි කරන්නේ. හරිද? ඔන්න ඕක තමයි ප්‍රශ්නේ. Okay, so again I'll give a brief description and then we will try these questions. Okay, so when you talk about friction, the friction එක අපිට මේ general topic එකකට විතර කරන්න බෑ. friction එක අපිට ඕනි විදිහට හැම වෙලෙම වැඩ කරන්නේ නැහැ. හරිද? friction should be studied considering two conditions. conditions දෙකකට තමයි මෙයා ගැන study කරන්න වෙන්නේ. First one static condition. කියන ස්ථිතික ඝර්ෂණය. Second one dynamic condition. ගතික අවස්ථාව. හරිද? එතකොට ස්ටැටික් කන්ඩිෂන් එකේදී ෆ්‍රික්ෂන් බිහේව් කරන්නේ එක විදියකට, ඩයිනමික් කන්ඩිෂන් එකේදී ෆ්‍රික්ෂන් බිහේව් කරන්නේ තව විදියකට. ඕකේ? ඒක තේරුම් ගන්න ඕනේ. ඕකේ ඩයිනමික් කේස් එක ලේසි. In dynamic case, the friction force is nothing but the product of the dynamic friction coefficient times the reaction force. හරිද? dynamic case එකේදී F equal mu r වලින් ඔයාලට කෙලින්ම හොයන්න පුළුවන්. ගතික case එක ගතික ඝර්ෂණයේදී friction ඒ කියන්නේ ඝර්ෂණ බලය mu r වලින් හම්බ වෙනවා. But in static case it's kind of different. In static case this friction force is kind of like a self adjusting force. Okay, so you know self adjusting forces. හරිද? අපි කියන්නේ මොනවද? සොයන් සීරුමාරු බල සිංහලෙන්. හරිද? self adjusting force. කියන්නේ ආ ඒ කන්ඩිෂන් එක තියාගන්න ඕනේ විදියට තමයි ඩිපෙන්ඩ් වෙන්නේ. static friction force එක තියෙන්න ඕනේ වැලියු එක. කියන්නේ motion එක static තියාගන්න. හරිද? static කියන එකේ meaning එක වෙන්නේ not moving කියන එකනේ. move වෙන්නේ නැතුව තියාගන්න තමයි එයාගේ වැලියු එක එයා හැම වෙලෙම adjust කරගන්නේ. හරිද? dynamic කියන්නේ moving. හරිද? කොහොම surfaces දෙකක් තියෙනවා නම් අපි දන්නවා surfaces rough වෙනකොට මේක අතර friction forces ඇති වෙනවා කොහොමද relative motion එකට opposite direction එකට. يعني relative motion එකක් ඇති වෙනවා නම් මෙහෙම friction forces එන්නේ මෙතනදී මෙයා මෙහෙට move වෙද්දී හදද්දී මෙයාගේ මත opposite direction එකට මෙයා මෙහෙට move වෙන්න හදද්දී මෙයාගේ මත friction force එක opposite direction එකට. හරි likewise. so static case කියලා කියන්නේ මේක move වෙන්න හැදුවට move වෙන්නේ නැහැ not moving. ඒතර ඒ stage එකේදී friction එක self adjusting තියෙන්න ඕන විදිහට තමයි ඉන්නේ. but in case dynamic dynamic වෙලාවෙදී කියන්නේ move වෙද්දී friction එක මෙහෙමයි කෙලින්ම. ඕක තමයි simple theory. හරිද? ඊළඟට ඔගේ තව limiting friction කියලා තව එකක් තියෙනවා. මේකෙදි කියන්නේ මේ අර static friction එක ගන්න පුළුවන් maximum value එක ගැන. මම කියවනේ මේ static case එකේදී මේක සංසිරුමාරු කියන්නේ self adjusting කියලා. self adjusting වුණාට එයාට යන්න පුළුවන් maximum limit එකක් තියෙනවා. That's what we call the limiting friction. හරිද? The limiting friction again can be found considering the limiting friction coefficient, or we say the static friction coefficient. And the limiting friction කියන්නේ static එකේ maximum value එක ඕනනම් මෙහෙම හොයන්න පුළුවන්. maximum value එක මෙහෙම හෙව්වට මතක තියාගන්න අර static case එකේදී හැම වෙලෙම friction එක maximum value එකට සමානක් නෑ. හොඳේ. අපි cases කීපයක් බලමු. okay බලන්න ඔතන friction එකේ එහෙම cases කීප ගැන තුනට අදාළ ඒවා මම questions දෙක ගානේ දාලා තිනවා. අර static case එකේ questions දෙකක් තමයි මුලින් තියෙන්නේ. හරි. first two questions. again there is another 15. හරිද? දෙවෙනි 15. read the question. A box of mass 5 kg is placed on a horizontal surface. The coefficient of static friction between the box and the surface is 0.3. If the horizontal force of 10 Newton is applied on the box, the magnitude of the friction force acting on the box will be. මේ බලන්න මේක past paper question එකක් නේ. මේක මොනවටද මේ දැන් මම දන්නෙත් නෑ මේ. still past paper question. So 5 kg mass එකක් තියෙනවා. හරිද? surface එකක් උඩ. and there is a 10 Newton force applied on it. අපිට දීලා තියෙනවා මේ static friction coefficient එක කියලා. So where this static friction coefficient comes? ඔය static friction coefficient එක එන්නේ limiting friction වලට. හරිද? ඒ කියන්නේ static එකේ maximum එක හොයන්න. static එකේදී friction force එක self adjusting. හරි friction force එක ගන්න යදාල condition එකේ තියෙන්න ඕනේ value එක. හැබැයි යාර යන්න පුළුවන් maximum එක දිනවනේ. උන් එක වන්න තමයි මෙයා ඕනේ. අපෙන් අහන්නේ දැන් මේ වෙලාවේ මේකේ තියෙන friction force එක කීයද කියලා. Okay. so මෙතනදී මේ object එක මත external force එක තියෙන්නේ opposite direction මෙහෙට නම් friction force එක එන්නේ අනිත් පැත්තට වෙන්න එපායි මෙහෙට. අපි ඉස්සෙල්ලාම අඳුර ගන්න ඕනේ මේ කේස් එකේදී මේක move වෙනවද නැත්නම් move වෙන්නේ නැද්ද කියන එක. හරිද? static ද dynamic ද කියලා. ඒතර ওই දෙක වෙනස් වෙන්නේ කාගෙන්ද? static එකයි dynamic එකයි වෙනස් වෙන්නේ limiting එකෙන්නේ. limiting තමයි static එකේ තියෙන බලන්න maximum value එක. අපි බලමු මෙතනදී මේ friction එකට ගන්න පුළුවන් maximum force එක කීයද කියලා. static friction එකට. දැන් අපි එළිම limiting කියලා කියමු. limiting friction. ගන්න පුළුවන් maximum value එක මට mu sr වලින් හොයන්න පුළුවන් නේ 0.3 times reaction is nothing but 50 newton මොකද reaction එක mg ට සමානයිනේ 15 newton ඒකෙන් මොකද කියන්නේ friction force එකට ගන්න පුළුවන් maximum value එක 15 newton friction force එකට ගන්න පුළුවන් maximum value එක 15 newton හැබැයි මෙතනදී static තියාගෙන 15 ඕනේද හරිද ඉතින් අඳුර ගන්න තියෙන්නේ මේක static ද dynamic ද කියලා මෙතන force එක දීලා තියෙන්නේ 10ක් විතරයි force එක 10ක් විතරයි නම් දීලා තියෙන්නේ අපිට මෙතන friction එක 10ක් තිබ්බනම් ඇතිනේ මේක නවත්තලා තියාගන්න only 10 newton force will be enough only 10 newton of friction is enough to keep this object static හරිද නැත්නම් not moving move වෙන්නේ නැතුව තියාගන්න 10ක් තිබුණනම් ඇති එන්න එහෙනම් මේක static condition එකක් මේකේ required friction is less than the maximum friction that means this is a static case so the friction force is 10 newton හරිද මෙතනදී එහෙනම් ඕනේ friction එක වෙන්නේ 10 newton හරිද රොතනදී friction force එකේ value එක 10 newton okay so 16th question again well, again that's a static case a block of mass simple m kept on a horizontal truck bed is at rest with respect to the truck when it is moving horizontally with a constant acceleration a the coefficient of static friction between the truck bed and the mass is u the friction force acting on the mass is given by okay මෙහෙම ට්‍රක් එකක් තියෙනවා මේ ට්‍රක් එක ඇක්සලරේට් වෙන ගමන් තියෙන්නේ හරිද මේක උඩ මෑස් එකක් තියලා තියෙනවා බ්ලොක් එකේ මෑස් එක m අර ට්‍රක් එක ඇක්සලරේට් වෙනවා මෙහෙට constantly a වලින් and they have said that this mass is at rest respect to the truck හරිද මේක ඇක්සලරේට් වෙද්දී even if this truck accelerates this mass is stationary or at rest respect to the truck bed මේකට සාපේක්ෂව මේක move වෙන්නේ නැහැ that means මොකද ඒක කියලා තියෙන්නේ නොකිය හරි අතන නොකිය කියලා තියෙන්නේ මෙතන move වෙන්නේ නැහැ කියලා. ඒ කියන්නේ static condition එකක් තියෙන්නේ කියලා තමයි දීලා තියෙන්නේ. අන්න static condition එක නම් මොකද්ද? If the condition is static, if the friction is static, then it works as a self-adjusting force. හරි. යාගේ තියෙන්න ඕනේ value එක මත depend වෙනවා. හරිද? එතන මේක stationary තියාගන්න නම් මොකද්ද වෙන්න ඕනේ? මේක bed එකට සාපේක්ෂව මෙයා static කියනවා මොකද්ද වෙන්න ඕනේ? If this mass is stationary or at rest respect to the bed, then this mass also should accelerate at the same rate නේ. lorry එක යන accelerate එකම mass එක යන්නත් ඕනේ. But how can this mass have an acceleration? So if you see the forces on this, there's the weight and the normal reaction, or the normal reaction එකක් තියෙනවා, but there is no any other horizontal forces unless the friction. Friction එක තිබ්බ නැත්නම් මෙතන horizontal forces නැහැනේ. So what happens is in this case the friction is the force which assists the motion. හරිද? يعني friction එක හැම වෙලේම යන පැත්ත කියන්නේ යන එක වළක්වන්න හදන්නෙත් නැහැ. එයා සමානට assist කරනවා. හරිද? ඒතර මෙතනදී static තියාගන්න නම් මේකේ horizontal එකම acceleration එක ගන්න ඕනේ. يعني truck එක යන acceleration මෙයාත් යන්න ඕනේ. ඒ acceleration හදලා දෙන්නේ friction force එකෙන්. So how to determine the value of friction force then? If the friction causes the acceleration, then the second law. So only horizontal force is friction. So F naught should be equal to mass times acceleration ma. So බලන්න ඔකේ දීලා තියෙන answers ma තියෙනවා. ඒක තමයි answer එක. හරිද? But how many students will think the answer is ma? ma කියලා කවුද answer එක හිතන්නේ? Most of the students will choose the answer either mu mg or ඔය ඊළඟට තියෙන mu mg plus a හරි mg minus a හරි මොකක්ද නැහැ. g plus a g minus a දැකලා තියෙනවද උඩට? ඔය මොකක් හරි එකකට තමයි ගහන්නේ. ඒක තේරුම් ගන්න හරිද? static case එකේදී friction එක තියෙන ඕන විදිහට තමයි ඉන්නේ. self adjusting. Okay, so 16th is fine. Now two limiting cases අන්න. limiting friction තියෙන ගණන් දෙකක් දීලා තිනවා. හරිද? එතන limiting කියන එකේ පොඩ්ඩක් topic එකේ දාලා තිනවා මේ. You see involving maximum minimum කියලා ඉපාවා. ඒ මොකක්ද ඒ කියන්නේ? So if you watch it closely So if you remember, when I'm explaining this friction, I said limiting friction is nothing but the maximum limit of static friction. Static friction එකේ කියන්නේ මේ ස්ථිතික ඝර්ෂණයේ තියෙන පුළුවන් maximum limit එක තමයි limiting friction කියලා කියන්නේ. හරිද? එතකොට එතනදී විතරක් friction force එකට මට equation ලියන්න පුළුවන්. limiting case එකේදී විතරක් FL කියලා ගත්තොත් FL is equal to mu s r. static friction coefficient times r. නැතුව static case එකේ තියෙන ඕනෙම වෙලාවක friction force එක mu s r දැම්මොත් වැරදි ඈ. ඒක තමයි මෙච්චර ළමයි පැහැදිලි කරේ. In static case friction is self adjusting. Okay, so දැන් මෙතනදී තියෙන මේ maximum කතාවක්නේ. يعني limiting friction කියන්නේ static එකේ maximum cases නේ. ඒතර අතර මේ limiting friction එකේ involve වෙන ගණන් වලදී what you have to observe is if the limiting friction is involved, you should understand that ඒ ගණන් වලදී මේ ගොඩක් වෙලාවට ඒ ගාන ඇතුලේ තියෙන term එක maximum or minimum එකක්. ඒ ගාන ඇතුලේ මොකක් හරි දෙයක් maximum වෙන කතාවක් හරි නැත්නම් minimum වෙන කතාවක් තමයි ඊතර අහන්නේ. Like for example, in the question they may have asked the maximum acceleration, the maximum acceleration of the truck bed. දැන් මේ ගාන දීලා you understand this. So if you see this relationship, once the acceleration is increased, or the acceleration එක වැඩි වෙන්න required friction will go up නේ. friction එක වැඩි වෙනවා. So there should be some maximum acceleration such that this condition is retained. මේක retain කරන්න පුළුවන් විදිහේ maximum acceleration එකක් තියෙනවා. ඒ කොතනදද? මෙතන friction force එකට එහෙම හැම වෙලෙම වැඩි වෙන්න බෑනේ. There is a limit for the friction that we call the limiting friction. හරිද? ඒතර මේ friction force එක limiting friction එකට ආවහම අන්න එතනදී තමයි maximum acceleration එක තියෙන්නේ. මේ විදිහට යන්න පුළුවන්. හරිද? එතනට වඩා වැඩිපුර acceleration එකක් ගන්න කිව්වොත් මේක move වෙනවා. rest එකේ ඉන්නේ. So අන්න ඒ වගේ හරිද? අර maximum acceleration එක හොයන්න කියලා තිබ්බොත් නැත්නම් මොකක් හරි minimum වෙන case එකක් හරි තිබ්බොත් අන්න ඒ තැන් වලදී තමයි ඔය limiting friction දාගෙන ගාන හදන්න ඕනේ. හරිද? So let's see the two questions. So first one, box A of mass 50 kg is placed on the horizontal floor bed of a lorry as shown in the figure. The coefficient of static friction between the box and the floor bed is 0.8, and the lorry accelerates along the straight horizontal road. The maximum acceleration the lorry can have so that the box will not slide the printing mistake slide over the floor bed is. දැන් මේකම තමයි අහලා තියෙන්නේ. හරිද? මේ විදියට දැන් මෑසස් වෙනේවා දීලා තියෙනවා. මේ විදියට ස්ලයිඩ් වෙන්නේ නැතුව හරිද? මෙතන ස්ටැටික් කන්ඩිෂන් දියාගෙන යන්න පුළුවන් maximum acceleration අහන්නේ. So what should you understand? Maximum acceleration happens when limiting friction is there. You see, higher the acceleration, higher the required friction force. So the highest friction force which can exist is the limiting friction. Okay, so again, if you apply the equation, you can find this F naught should be equal to ma. හරිද? මේක තාමත් හරිනේ. Okay, accelerator නම් F naught equal ma කියන හරි. And again, if the friction is limiting, then we can use the other equation. Friction also should be equal to mu s times r. Reaction කියලා කියන්නේ ඉතින් mg නේ. r equal mg. So I can equal these two formulas. So mu s mg is equal to ma. So the maximum acceleration you can get is mu s g. Mu s is 0.8, acceleration 8 meters per square second. So the answer should be the third one. You see, so what happens when what happens when the limiting friction is involved is, other than the same normal equations, you can write this equation. Limiting friction එක තියෙනකොට අර F equal mu r කියන එක දාන්න පුළුවන්. එච්චරයි වෙනස. Okay, so 18th. Again, the same kind of equation. A trolley A is on a vertical horizontal track B trolley A is on a horizontal track. B is a wooden block of mass m. If the coefficient of static friction between the trolley and the block is the minimum. I think there is a printing mistake. Coefficient of static friction between the trolley and the block is mu. Then the minimum acceleration of the trolley that is required to prevent the block from sliding down is. හරි. ඒ කියන්නේ ඔතන දීලා තියෙන friction coefficient එක mu නම් what should be the minimum acceleration that should prevent the block sliding down. අපි block එක slide down වෙන එක prevent කරන්න පුළුවන් minimum acceleration එක මොකක්ද කියලා අහන්නේ. So how this sliding down is prevented? So you should understand what should happen when AB exists like this. When the system is accelerating to this direction, because of this contact, or the method in contact there will be a reaction force first. Then on B, if I consider the forces on B, A කියන කෙනා ඉතින් රෝද වලින් දාලානේ තියෙන්නේ. B නේ වැටෙන්නේ නැත්තේ. ඒතර B ගේ forces ගත්තොත් B මත තියෙනවා mg. හරිද? එයාගේ weight එක තියෙනවා. mg is there. And this reaction is there. But ඒතර මේ දෙක විතරක් තිබ්බොත් මොකද්ද වෙන්නේ? If only these two forces exist, then because of this mg, this should slide down along this surface. And B කියන කෙනා slide down වෙන්න ඕනේ. But it does not. ඇයි? පල්ලෙහාට එන්නේ නැත්තේ ඇයි? That's because of the friction force. So මේක weight එකකින් හින්දා පල්ලෙහාට එන්න හදද්දී friction එකකින් යන්න එපා කියලා අල්ලන් ඉන්නේ. Okay. So they are asking to calculate the minimum acceleration. අන්න minimum, if the term minimum is there, ඔය minimum acceleration කියන වෙලාවෙදී අනිවාර්යෙන් එනම් limiting friction එකත් එක්ක තමයි යන්නේ. ඒ කියන්නේ friction එක තියෙන පුළුවන් maximum value එකේ තියෙන්න ඕනේ. That means you can write another equation for the friction. Okay, let's try to write equations here. So if first thing, if this mass does not slide, make a slide වෙන්නේ නැහැ කියලා කියන්නේ මෙයා vertically equilibrium එකකින් ඉන්නේ. If the vertical equilibrium is considered, then the friction force should be equal to mg, its weight. First relationship. හරිද? මේක මේ static condition එක සලකලා ගත්තේ. Then again, when the limiting friction is considered, the friction force again should be equal to mu times r, the reaction. Here you have to note that the reaction is not equal to mg. සාමාන්‍ය cases වල වගේ r equal mg කියලා දාන්න බෑ මෙතන. මෙතන තියෙන horizontal reaction එකක් නේ. So this horizontal reaction comes due to the acceleration. If you remember, when the system is accelerating, this r force is the one which accelerates this simple mg. r හින්දා තමයි simple mg accelerate වෙන්නේ. So if you consider the acceleration and put an f equal ma horizontally to b, b එක consider කරලා horizontal f equal ma එකක් දැම්ම නම් ඔයාලට r evaluate කරන්න පුළුවන්. R should be equal to m times the acceleration a. So here mu times r is equal to mg ne, ma ne. So mu ma. So this is the second equation for the friction. So you have two equations. You see, when the limiting friction is involved, you can obtain two relationships for the friction. One from the static condition, one considering the static condition, the other one from the limiting friction formula, mu r. So when you make these equal, mg is equal to mu ma. So acceleration is equal to here g over mu. Acceleration is equal to g over mu. So the minimum acceleration preventing sliding down is g over mu towards right. Okay, so the answer should be the fourth one. Fourth answer. Okay. This is a dynamic case. Dynamic case is simple, very simple, just mu r. Okay, friction is always equal to mu r. So 19. Let's read the question. Four Newton is kept on another block B of weight 12 Newton, which rests on floor F as shown in the figure. F කියන floor එකේ මෙතන මෙයාගේ weight එක 12 Newton, මෙයා 4 Newton. Okay. If the coefficient of static friction between the A and B are B and F are same and is equal to 1 over 4, the minimum force P required to drag B to the left is. Okay, B කියන කෙනාව දකුණට මෙහෙට අදින්න left වලට අදින්න required minimum force මොකක්ද කියලා අහන්නේ. Again, you can mark the forces. හරිද? එතන මේකේ මම horizontal forces විතරක් mark කරන්නම් vertical ඒවා නැතුව. So if this is pulled this way, මේ පැත්තට ඇදලා තියෙනවා නම් friction force on this side should be like this නේ. මෙහෙම load. And again මේ surface එකට සාපේක්ෂව මෙයාව මෙහෙට අදිනවා කියලා කියන්නේ මෙතනදි friction එකක් එනවා. ඒකත් මොකද මෙතන contacting surface එකක් නේ. Friction forces will be there at each contacting surface. So I'll take this one as F1 and this is F2. And again, friction forces are also forces. So they should be generated as couples. Couples is තමයි එන්නේ. So if there is a friction force on this thing, there should be another friction on A as well. But it is balanced with this tension. මේ string එක දාලා මෙහෙම attach කරලා තියෙන්නේ මේ මෙන්න මේවා balance කරන්න තමයි. මේක අපිට වැඩක් නැහැ. So what is the required minimum force? Minimum force is equal to F1 plus F2. So how to determine F1 plus F2? Again, මේක අර dynamic case එක consider කරනකොට මේකත් අර limiting case එකකට මේකක් තමයි. දැන් minimum force එකක් ගැන අහලා තියෙන හින්දා. හරිද? මෙතනත් static friction coefficient නේ දීලා තියෙන්නේ. එතකොට මෙතනත් ඔයාලට consider වෙන්නේ limiting case එක. So at limiting again friction forces are equal to mu times r. හරිද? mu r වලින් ගන්න පුළුවන්. So first one, F1 is the friction force at the lower surface. So mu v is 1 over 4. Reaction. What is the reaction at this point? तर මෙතන reaction එක තේරෙන්න ඕනේ. මෙතන reaction එකට affect වෙනවා උඩ තියෙන masses දෙකම. කියන්නේ ground එකෙන් මේ දෙන්නවම දරාගෙන ඉන්නේ. So here 4 Newton, here 12 Newton. Almost, I mean, collectively this 16 Newton. So the reaction is 16 Newton plus F2. The friction between these two surfaces can be calculated. Again, friction coefficient mu. Reaction. මෙතනදී reaction එක use වෙන්නේ කාටද? මෙතන reaction එක S නම් that is used to balance capital A only. That reaction is used to balance A in the vertical direction. So S is equal to 4. මෙයාගේ weight එක 4 නම් S වල value එකත් 4. So 1 here 4. 4 plus 1 is equal to 5 Newton. So for the 19th question, answer is 5 Newton. And I'll do the 20th one as well here and 21. මේ තුනම කළා ඔයාලට පොඩ්ඩ time එකක් දෙන්නම් මේක write down කරන්න. So as shown in the figure, a force P is applied on the mass 2 kg lying on the horizontal surface. The coefficient of kinetic friction between two surfaces is mu equal 0.5. 0.5 low. If the object moves with a uniform velocity, the normal force are acting on the object is okay. මේ normal force එක කීයද කියලා අහන්නේ. මේක constant velocity එකකින් යනවා නම්. Okay. So the kinematic friction coefficient එක අපිට දීලා තියෙනවා 0.5 කියලා. So we will mark all the forces. So here the P is there and the weight, this is 20 Newton, 2 kg නේ. And here again I have to take the components of these force. මේකේ components ගන්නවා. එතන මෙහෙට තියෙනවා P cos 45. Cos 45 and 1 over root 2 නේ. එතන මේක P over root 2. මේ පැත්තටත් එන්නේ P over root 2 කියලා. හරි. මොකද P cos 45 cos 45 කියන්නේ 1 over root. And what are the other forces? Weight, reaction, friction. Sorry, weight, reaction, the other external force, and the reaction. So බලන්න මේ මෙහෙට horizontal p over root එකක් ඇවිල්ලා තියෙනවානේ. horizontal forces විතර දැන් මෙතන මාක් වෙලා තියෙන මේක විතරයිනේ. So it should be balanced. The friction force should oppose that force. දැන් friction force එක හැම වෙලේම motion එක oppose කරන්නේ. So they are asking to calculate the reaction. So if you write the vertical equilibrium, හරිද? දැන් vertical equilibrium තියාගන්න reaction එක ඕනේ වෙන්නේ. So reaction should be equal to 20 plus p over root 2. But reaction එකට හොයන්න බෑ p දන්නේ නැතුව. P is there. So I'll take this equation as 1. So I have to consider the horizontal motion as well. And in the question, they have given that when this p is applied, this object moves with uniform velocity. මේක දීලා තිනකොට මේක uniform velocity එකකින් යන්නේ. So if the velocity is uniform, that means velocity is constant නේ. Velocity constant කියලා කියන්නේ horizontal forces balance වෙන්න ඕනේ. That means p over root 2 should be equal to friction force F naught. F naught is what? Here මේක move වෙනවා කියලා කියන්නේ dynamic case එකක්. So in dynamic case, friction force can be evaluated using mu dr. Mu d is given 0.5. Okay. So p over root 2 is equal to 0.5 r. Now what you have to do? First one එකට substitute කරගන්න. For the first one, r should be equal to 20 plus p over root 2 කියලා කියන්නේ 0.5 r නේ. 0.5 r. Then if you solve this, 0.5 r is equal to 20, then r is equal to 40 Newton. So the reaction is 40 Newton, which is the fifth answer. Okay. Fifth answer. 21st. We will see that one as well very quick. An object lies on a horizontal table. When the object is pulled by horizontal force F that increases uniformly from 0, the variation of the friction force F acting on the object is best represented by the graph. Okay, so there is an object kept on a table and there is a force. The force එක 0 වලින් වැඩි කරගෙන යනවලු. They are asking the behavior of the friction force. Again, theory question නේ. So initially this is at static condition. Static condition එක මොකක්ද කිව්වේ? Friction එක self adjusting. Self adjusting means friction adapts. හරිද? මෙතන මේක move නොවී තියාගන්නම තමයි බලන්නේ. Static condition එකේදී move නොවී තියාගන්න මොකද වෙන්න ඕනේ? If this does not move, then the friction force should be equal to the applied force, isn't it? අර දීලා තියෙන force එකමනේ වෙන්න ඕනේ. And then it will move to the dynamic case. So in the dynamic case, friction force can't do like much. They can't do much. Friction force is just mu dr. It is constant. So the graph should have two sections. One for the static variation, the other for the dynamic variation. So initially static variation. හරිද? මුලදී static variation තියෙන්නේ. The friction force එක external force එක සමානයි. So if you draw the graph, if you take this to the y-axis and this to the x-axis, y equal x. Variation should be like y equal x. So initially, until static, variation is like this. And then, ඔන්න මෙතන තමයි අර limiting කතාවට එන්නේ. free එක ගන්න පුළුවන් maximum value එක limiting. ඔතනට ආවම පස්සේ ඔතන වඩා තව වැඩි වෙන්නේ දෙයක් නැහැ. හරිද? ඊට පස්සේ dynamic. Dynamic වලදී mu dr නේ. මතක තියාගන්න මේ mu dr කියන value එක limiting කියන පොඩ්ඩක් අඩුයි. limiting friction එකට වඩා පොඩ්ඩක් අඩුයි dynamic friction එක. කියන්නේ constant තියෙන කතාව වෙනම එකක්. constant තියෙනවා. ඊට පස්සේ ආයි dynamic case එකේදී friction force එක වෙනස් වෙන්නේ නැහැ. Constant still stay constant. But the value is somewhat less than the limiting. So the graph should be the third answer. variation is the third one, 21st. So that's about the friction, and there are two questions more like marking the friction force. හරිද? friction එක mark කරන recent years වල හරිය එකක් තියෙනවා. මේකෙනුත් couple එකක් මොකටද දාලා තියෙනවා. ඒකත් බලත හැකි අපිට. Okay. I just erased the board නේ. So දැන් කරන දෙයක් නෑ මේ එක පොඩ්ඩක් ආයෙත් රිවයිස් කරලා බලන්න බෑ. I rewind කරලා බලන්න පුළුවන්. So we will just quickly look at 22nd and 23rd questions. 22nd, which of the following figure shows the direction of the friction forces acting on two tires of a bike when it is pedaled by the rider on the surface with friction? Friction එක තියෙන surface එක bike කෙනෙක් bike pedal කරන් යද්දී friction forces එන්නේ කොහොමද කියලා mark කරන්න තියෙන්නේ. හරිද? Again here simple theory is used. හරිද? simple පොඩි වැඩක් තියෙන්නේ. So මේක මෙහෙම ඔළුව තියාගත්තනම් හරි. විතරම අපි locomotion වලට friction නැතුව බෑ. ඉතින් මේ move වෙන methods ගොඩක් ඒවට ගැන land එක through move වෙන cases වලදී අපිට friction නැතුව බෑ. friction එකෙන් තමයි. friction force is the one which induces the motion. So even when we are walking, what happens is මේක අපි walk කරද්දී මොකද්ද වෙන්නේ? We are just sliding our leg on the floor. හරිද? අපි අපේ leg එක floor එක දිගේ slide කරනවා පිටිපස්සට. So what happens when we slide the leg මේ in backward direction මේක පිටිපස්සට slide කරද්දී මොකද්ද වෙන්නේ? මම පිටිපස්සට slide කරන හින්දා friction force එක එනවා ඉස්සරහට. හරිද? So because of this friction only we move forward. අපි ඉස්සරහට යන්නේ මේ friction එක හින්දා. මේ ඇති වෙන friction force එකකින් තමයි අපි ඉස්සරහට යන්නේ. So that's valid for vehicles as well. හරිද? vehicle move වෙනකොටත් ඕකම තමයි වෙන්නේ. හරිද? let's say there is a vehicle. So මේකේ vehicle එකේ engine එක power එක දෙන මේ wheel එකක් තියෙනවනේ. ඉතින් මේ දින engine එක engine power එක දීලා තියෙන්නේ මේකට. So initially the vehicle is at rest. කොහොම තියෙනවා. So engine power එක දුන්නාම මොකද වෙන්නේ? So when the engine power is given, the engine rotates the wheel. engine power එක දීලා තියෙනවා නම් wheel එකකට power එක දුන්න ගමන් ඒ wheel එක rotate වෙන්න ගන්නවා. rotate වෙන්න ගන්නවා මෙහෙට. මෙහෙම පිටිපස්සට. So when this motion is induced, හරි මේ motion එක ආපු ගමන් මොකද වෙන්නේ? Now you can see this lower surface of this tire is trying to move backwards. හරිද? දැන් lower surface එක නිකන් අර earth එකට related පිටිපස්සට යනවා වගේනේ හදන්නේ. Then what happens is the friction force is always opposing the motion. හරිද? දැන් මේක පිටිපස්සට යන්න හදන හින්දා friction force එක එනවා ඉස්සරහට. Okay, sorry, the friction force comes forward. So because of the friction vehicle starts to accelerate. හරිද? මේ friction force එක හින්දා තමයි vehicle එක accelerate වෙන්නේ. ඔය friction එක තිබ්බ නැත්නම් vehicle එකකට රෝද කරකවල ඔහොම යන්න බෑ. හරිද? හොඳම example එක තමයි දැන් මඩි road එකක vehicle එකක් යනකොට මඩි road එකක vehicle එකක් යනකොට අපි accelerate එක පාගන තරමට මේක යනවද? යන්නේ නෑනේ. වෙන්නේ මේ තියෙන wheel එක slide වෙනවා. හරිද? ඒ wheel එක slide වෙනවා කියන්නේ මොකද්ද? wheel එක slide වෙනවා කියලා කියන්නේ මේක කොච්චර පිටිපස්සට කරකුණත් ඉස්සරහට friction එකක් ගන්න බෑ. හරිද? මේක මඩි road එකකදී වෙන්නේ අතරම friction එක 0 වෙන්නේ නැහැ. smooth case එකක් වගේ තමයි එතන වෙන්නේ. මේක මේ තියෙන road එක smooth වෙනවා. So when it becomes smooth, then the friction force will be 0 නේ. So how faster the wheel rotates, there will be no any friction develop. කොච්චර හයියෙන් මේ රෝද කරපුණොත් friction එකක් එන්නේ නැහැ. friction is 0. so ඕක තමයි ඒ කියන්නේ ඒතර වාට එතනින් තේරුම් ගන්න තියෙන්නේ friction එක නැතුව move වෙන්න බෑ. so when the power is given, the wheel will rotate, so it will induce friction forward. Because of that friction the vehicle accelerates. ඒකින්ද accelerate වෙනවා. හැබැයි engine power එක දුන්නේ නැති wheel එක තියෙනවනේ. දැන් engine එක power එක දෙන wheel එකනේ අපි බහින් කරකවන්නේ. ඒ කරකවද්දී friction එකෙන් engine එක accelerate වෙනවා. so accelerate වෙන්න ගත්තාම දැන් මෙයා ඉස්සරහට යනවනේ. මේ wheel එක දැන් ඉස්සරහට යන්න ගන්නවනේ. so when this wheel begins to move forward, what happens is the friction will be opposing its motion. simple. so කරකවන්න නැති රෝදේ තියෙනවනේ. ඉති effort එක දෙන්නේ නැති wheel එක නිකම්ම ඉස්සරහට යන්න හදනවා. يعني මේක accelerator ගත්තාම මෙයා නිකන් ඉස්සරහට යන්න හදනවා. so එයා ඉස්සරහට යන්න හදද්දී friction force එකකට force කරනවා. so that's how the friction is generated on the other way. so these two for the question number 22 and 23 for both the same theory is applied. මේ කතා කරපු එකමයි. so 22nd එකේදී දැන් මේ බයික් කෙනෙක් මේක පැඩල් කරන එක තියෙන්නේ. so අපි පැඩල් කරද්දී මොකද කරන්නේ? අපි පැඩල් කළා අපි කරකවන්නේ මෙන්න මේ back wheel එක. so when the back wheel is rotated, what happens is the back wheel is trying to do a motion backwards relative to the ground. so when it try to move backwards, the friction force will oppose. that means this bike will accelerate forward. there will be a friction opposing this rotation. මේක rotation වෙන්නේ අර පැත්තට. ඒතර ඒක rotate වෙන එකට oppose කරන friction එක එනවා. so because of this friction this will accelerate. so when this accelerates, again the friction will be opposing on the forward road again. ඒක forward wheel එකේදී දැන් අර ඒක නිකන් යන්න බලාගෙන ඉන්නේ. හරි. මෙයා ඉස්සරහට යනවා හදද්දී friction එක oppose කරනවා. so the friction on the forward wheel should be like that. so the correct answer should be the second one. and for the 23rd, so if you read the question, they are asking there are two vehicles A and B. A vehicle එක කියලා කියන්නේ engine එක couple කරලා තියෙන්නේ front wheels වලට. B වලදී rear wheels. okay. like this. so in A it is front wheels and B it is rear wheels like this. A වලදී front wheels, B වලදී rear wheels. so මේ පැත්තට තමයි move වෙන්න හදන්නේ. so friction forces mark කරලා දෙන්නේ කොයිකද කියලා අහන්නේ හරියට. so කොහොමද වෙන්න ඕනේ? so to move this direction, because of the engine power this wheel rotates like this නේ. මේ විදිහට මේ wheel එක rotate වෙන්නේ ඉස්සරහට යන්න බලාගෙන. so rotate වෙන ගමන් the friction will come forward, assist in the motion. මේ friction එක assist කරනවා. F1 කියලා ගමු. but when this vehicle starts to accelerate because of this friction, මේ friction එකකින්ද accelerate ගන්න ගත්තාම the other will try to move forward, then the friction will be opposite. F2 like this. so for the vehicle B, when vehicle B is considered, it's trying to again accelerate this way, but the rear wheels are powered now. How are the rear wheels powered කරලා තියෙන්නේ? and the rear wheels trying to rotate like this. Initially when the engine power is given, rear wheels like rotate like this, then the friction force will be forward, F1. so when the vehicle starts to move forward, this will try to move forward, then the friction will oppose it. so the friction on the forward wheel should be to the other direction. that means this is correctly given in only the option the fourth one, in the fourth option. okay. so that's about 23rd question. and then we comes to this FT curves section. okay, so let's quickly complete that as well. so you have to make recap and just sketch the diagrams for now. I'll quickly revise the FT curve section as well before ending the session. So you can work on that as well. මේකත් අපිට ටක් ගාලා ඒක කරලා ඉවර කරන්න පුළුවන් මේ ඔයාට මේ week එකේ මේක cover කරන්න පුළුවන්. Okay. So FT curves දීලා තියෙනකොට. So in past paper questions you will find a few questions like 4 to 5 questions in the previous years coming from FT curves. That's why I included this here. So when an FT curve is given, using this FT curve, what you can obtain is the area under the curve. Making what ගන්න පුළුවන් වෙන්නේ curve එකේ area එක. Remember, area under FT curve is equal to change in momentum of the object. ඒ කියන්නේ මොකක් හරි object එකක් මත force එක time එකත් එක්ක vary වෙන curve එක වලට දීලා තිබ්බොත් හරිද? මොකක් හරි object එකක් මත තියෙන force එක time එකත් එක්ක vary වෙන curve එක වලට දීලා තිබ්බොත් ඒ curve එකේ area එකෙන් ඊයදාල object එකේ change in momentum ඔයාලට calculate කරන්න පුළුවන්. Momentum change එක. So how do you write an equation for the momentum change? By mv minus u. So this is a simple relation. So we will try to do this question. First one, a body of mass 5 kg is subjected to a force F which varies with time t as shown in the graph. And ඔතන question එකේ භාගයයි type වෙලා තියෙන්නේ. They are asking to calculate the momentum change. හරිද? The momentum change තමයි හොයන්න කියන්නේ. So how to find the momentum change? So simply momentum change is equal to area. Change in momentum, I can write it like delta mv. Momentum change is equal to area. So calculate the area under the graph. So this is a trapezoid. Trapezoid area can be evaluated just by summing up the two sides to parallel sides, which is 6 plus 8, and dividing by 2 and multiplying by the perpendicular height 10. So once you do this, you will find this is 70 Newton seconds. Area is 70. So which answer? Answer is the third one. Okay, easy. And 25th. I think I'll keep 25th. I'll do 26th. 26th එක මම කරන්නේ 25th එක ඒ වගේමයි පොඩි වෙනසයි තියෙන්නේ හරිද? So in 26 also force F varying with time is indicated in the figure is applied to a wagon of mass 10,000 kg which is initially at rest on frictionless horizontal rails. After 100 seconds the speed of the wagon in meters per second. හරි. So මේ දින FT curve එක දීලා දිනවනේ. මේක මේ wagon එකක් මත දීලා දිනවා මේ force එක. හරි force එක දීලා තියෙන්නේ wagon එකක් මත. mass එක දීලා තියෙනවා 10,000. Initially zero velocity loop. 100 seconds ගියාන් පස්සේ final speed එක අහන්නේ අපේ. So කොහොමද හදන්නේ? FT curve එක දීලා දිනවා ඔයාලට area එක විතරයි ගන්න පුළුවන්. Area should be equal to momentum change. That's the equation නේ. So area how to calculate? So note that in this FT curve the force varies both in two sides. Or මේ sides දෙකේම vary වෙනවනේ. يعني initially the force is positive and finally the force is negative. Negative 500. Initially it is 10,000. Sorry, 1,000. මෙතන area එක calculate කරද්දී මතක තියාගන්න. Just remember the area should be calculated by considering the algebraic sum. Algebraic sum එක ගන්න ඕනේ. That means the areas above the time axis should be taken positive. The areas below the time axis should be considered negative. So what is the total area then? Total area should be 10,000 into 50 and then subtract you should subtract 500 into again the time is 50 හරිද? එතන තියෙන rectangles දෙයක් නේ. මේකේ dimensions අරගෙන areas calculate කරන්න පුළුවන්. Just refer the diagrams. So it should be equal to the total mass is 10,000 times the final velocity v, initially 0, and here it is 50,000. Here it is 25,000. So when you subtract it, it will be 25,000 is equal to 10,000 v. So these three zeros will be cancelled, and the final velocity you get 2.5 meters per second. Okay, so that's how you do the 26th question. Okay, so now we can see it. Okay, so we covered I think Newton laws, then friction, as well as this FT curves thing. Okay, so still only remaining part is the momentum conservation, and now I think it's not the time to do that part here. So we will try to solve some few questions of momentum conservation in the second recap session, which will be occurred in the next Saturday. So at this point, we will stop the discussion. So if you have any questions regarding what we have discussed in this class, please put through the chat. Otherwise, we can end the session in few minutes. Okay, I think we have solved nearly 28 questions within these 3 hours, including MCQs as well as those short type questions. I think you have achieved something from the session. Then, so if you have no questions, then we can end the session. Hope you all got something. So try to continuously work with the schedules and recap all the syllabus in 20 days. Okay, so within this week, you should all I mean, you all should follow through the respective sections which we have done questions and recap. So thereafter, in the next session, before the next section, you may give me if you have any questions like and then we will can continue with the next set of sections in the next recap session. Okay, so until then, goodbye to good night.